What's up, everyone? So we are starting the stream here. Algebra 1, we're doing June 2018. First off, thank you all for being here. We have 50 people here already, so thank you all for joining the live stream. So we are going to get going here. I'm just going to go ahead and scan the chat. I noticed there are some questions already about what do you need to pass. So if I look at this Regents here and I scroll all the way to the end, we're going to see here. So let me just get the scrolling going here. You'll just have to excuse me. My kids are not asleep yet. That's why I do these streams very late, because they make a lot of noise. But they will be asleep somewhat soon. So actually, let me go and find the full test here from this website, and I will pull up the scoring for this, because what do you need to pass? And it depends on your goal. Some of you are going into this with different goals here, so I will screenshot this and we'll see. What did you need to pass this Regents? So if we look here, not the best screenshot quality, but for this particular Regents here, if you look, what we've got here is we have for a 65, you would have needed 26 raw score points. That is only 13 multiple choice questions you need to get right. Now, don't just aim for 13 questions correct. Aim really high. Yeah, I need an 80. If you want an 80, like, aim for as high as possible. And then, if you lose a few points here and there, then you'll be fine. In 2023, it's just about the same expectations of all of you. Okay, so it's going to be roughly the same, somewhere in this neighborhood here. Anywhere from like a 26 to a 28 should seal it. A 95 means that you basically, let's see, a 95, they don't even give you a 95 that year, so you only have the option of getting a 96. That's strange. It's a weird scale. Yeah, the curve is insane, so talking at Caitlin here, the curve really helps people out in the beginning. It's like very steep in the beginning, and then it levels out. All right, so it's not the most pleasant of curves here. So let's see. So we have, let me just take a look. Yeah, like something like a 94. If you get an 81 out of 86, so you look at this. See, that's exactly a 94. So if you want to get a 94, you got to get a 94. If you want to get a 65, 26 out of 86, that gets you, that's 30% of the test correct. So to get a 65, you need somewhere from a 30%. 85 would be, wow, look at this, 3 ways to get an 86. 85 that year was 67 out of 86. So for this, that's a 78%. All right. So yeah, you could see here that they're not very forgiving as you want to get a higher score. But for the lower scores, if you just want to pass, then yeah. This Regents does have the arithmetic sequences. So yeah, my school is going to give you 40% extra on our test for our average. Oh, okay, for your average. Yeah, every school's got different policies here. So yeah, that depends on your school's policy. But look, the general thing, I would tell you this, because I teach, this year I taught AP Calculus, BC, and I teach pre-calculus. But algebra is just, I know algebra. That's why I'm doing this live stream. And I'm looking to reach more audiences. I did a live stream for AP Calculus, and I thought it was pretty successful. So I figured, why not reach out to, the rest of New York State and be the Regents guy for algebra, geometry, and algebra 2. So that's my goal here. That's why I'm doing all this. And but I can tell you this, as someone who teaches pre-calculus and AP Calculus BC, your algebra skills are so important. So like, yeah, get the 65. So like, you could graduate high school. But if you want the rest of math to be like not so tough, whether or not you learn it by tomorrow, like make it a goal to get good at algebra, because it will make the rest of math like much more doable. Geometry is kind of like a break from things. Like you need some algebra skills, but geometry is kind of like its own beast. Like the hardest equation you'd have to be able to solve in geometry would be like, all right, like 2x plus 10 equals like 3x, I don't know, like minus 5 or something. Like like a basic equation like this, like that's something you could run into in geometry, maybe like a quadratic here or there, but it's nothing like what you're going to run into like on this Regents or on the Algebra 2 Regents when that day comes. All right. So any other questions? What year is this test? This is, let's see here, June 2018. Yeah, so June 2018. Maybe I will edit the, I wrote June 2000. Yeah, just know, yeah, it's the June 2018 test. So if you want to follow along, you could go ahead and download it. All right, now I'll show a mix of calculator stuff and no calculator stuff. First thing you should know how to do is reset a calculator. So second plus 712. Because chances are when you go to your Regents, the proctor is not necessarily going to be a math teacher. So they have no idea how to use this thing. You would be the one to teach them how to use it. So remember, press second, memory. This is assuming, of course, you're using a TI, like a Texas Instrument calculator. And then 712, that resets it. And that puts it in like standard mode here, where everything is like in factory setting. All right. So I'll show a mix of styles here for like how you want to solve stuff. For the first question here, I mean, this one, there is a few ways you could do it, but honestly, to just start plugging in answers is not going to be nice. Like you do want to show up to the Algebra Regents knowing how to do some algebra. The second question, I'll show you how to do with the calculator, but something like this, my first instinct is to take this 4p plus 2 is less than, and I would distribute this 2. Okay, so this is the distributive property. So I'm doing 2 times p is 2p plus 2 times 5 is going to give us 10. Okay, so that gets us our first step. And now this, what I'm thinking of as I'm doing this is like reminding me of if I were solving, let's say 4x plus 2 equals 2x plus 10. So it's basically the same techniques that you're going to be using here to solve this. However, it's just a less than sign instead of an equal sign. And when we do this, like first order of business here, I would be to move the p terms to both sides. So I do minus 2p on the right, and I would do minus 2p on the left, like this. These are going to cancel, and you have 4p minus 2p is 2p, plus 2 is less than just 10, because this canceled out. All right, and these combine, you just do the subtract the coefficients. 4 minus 2 is 2. So from here, what you want to do is you're going to subtract 2 on both sides. And from here, now we look over here, the 2 minus 2 cancels, and we're going to be left with, we're going to have 2p is less than 8. Okay, because 10 minus 2 is just going to give us 8. And then we divide both sides here by 2, and this is going to tell us p is less than 4. All right, so choice 4 is our solution. Now, you have 3 hours for this thing. So, I mean, something you could test out here, if you think about it, you could plug in a number here that's less than 4, like let's say 0 is less than 4 to see that it checks out. And one thing, I strategically picked 4. I mean, technically, I could say, oh, like, negative 100 is less than 4. But I picked 0 because 0 is not less than negative 6. Okay, so like when you think of the number line here, like here's 0 and here's negative 6. If I, p is less than 4, I just need everything here that's less than 4. But if I had p is less than 6, that would only be the numbers to the left of negative 6. So by picking 0, that's something that's greater than negative 6, but less than 4. And if you plugged in 0 for p, notice like this would work out nicely. It would give you 2 is less than 2 times 5, and 2 is less than 10 is a true statement. So like, that's like not necessary. You don't have to check your work like this, but that would give me peace of mind to know that I did this right. Okay, so that is solving an inequality. The second question should give you more hope because this you get to do in a calculator. All right, 2x squared minus, so this you just go to the y equals. 2x, the square button is here, minus 3 square root is second x squared. All right, like this. And hit the right arrow, and then you want to know what is k of 9. So you go here, and you could scroll to 9, and you're going to get 153. Okay, so k of 9 is the y value when x equals 9, and that's 153. So I would say k of 9 equals 153. Remember, this means, in other words, when I see that, I'm asking myself, what is the y value? So what is the y value when x equals 9? Okay, like that's really what that notation means. Because some people read this and they're like, do I do k times 9? K of 9 means just plug in. You could do this by hand, but you're only risking things. If you want to know a nice shortcut too, you see how I wrote this in the y equals? If I go to the main screen and I press second trace, y1, we type this in the y1 spot, and I could just put a parenthesis 9 and close it and press enter. And that's kind of like saying f or k of 9 equals, because we wrote k of x in the y1 spot. So alternate way of doing this, it's pretty nice. Could I do that again? Oh, the calculator magic? Yeah. So the calculator magic, you press second. I'm sorry. My kids are yelling in the background, so I'm doing my best to multitask here. But they're having fun right before they go to sleep, and then I'll be able to think better. So I'm going to press alpha trace. You see how it pulls up all this stuff? And there's a spot for y1. I put a parenthesis, a 9, and I close the parenthesis. If that doesn't work, you could press the vars button. You scroll to the right. You go to function, and y1 is located here. You just press 1. And same thing. All right, but if you have a newer calculator like the TI-84 plus CE, you could just press alpha trace and it pulls up the shortcut right on the main screen. Okay. Oh, Inspire. I'm sorry, Caitlin. This app only has the 84 plus CE. That's one of those things, like I'll tell you, that calculator could go to outer space and back. It could do amazing things. But my school only has the 84 plus CE. The Inspire ones are like really impressive what they could do. I would honestly just do like a quick Google search. Otherwise, for the algebra regions, you just need to press second graph and like go to the table and identify the y value. When you get to AP Calculus, it helps to know these function tricks. But, you know, you will have a long time before you're at a class like that, so you're fine. Okay, so this one, if you really had to, all right, I don't recommend this because this is for the people, if you just want a 65. All right, so this is kind of like a cheat code. I shouldn't be showing you this, but whatever. So 3x squared plus 2x, and then minus 3. And then minus 4. Like, let's say you're terrified of algebra. You're looking at that like, there's no way I could do this. All right, eventually you should be able to do this. But let's say you're like nervous for tomorrow. Like, I can't do this by tomorrow. You could type 13x. Oh, well, whatever. I guess they just, that looks silly because that should be an x squared. So I can already tell that's not the answer. But I know it's going to work out to choice 2. So I just write in choice 2 now. So negative 13x squared plus 34x. All right, I'm going to show how to do this by hand because if this shows up in the free response part of the test, you can't do it this way. Well, if you do it this way in the free response part of the test and you just put the right answer, no work shown, you get 1 point. So once again, for the people that are nervous about passing, like you could just do this. Now I press second graph. And I look, this was the question. This was choice 1, choice 2. You see how y1 and y3 match? Every number in y1 and y3 are the same. So that means like this was choice 2, the y3. Like if I just screenshot this and drag it over here. So we look here. And so like this column here, this was the question. Or like the original. So that was the question. And this was like choice 1. And this was choice 2. And I'm like, oh, these match. So because they match, I'm like, all right, choice 2. But once again, that's not going to be how you're going to do every question on the Regents. Like, this is like kind of dishonest, but depending on like the student I had and what their goals were, like if you're going like the STEM route, you know, you want to be like an engineer or something, like you got to know how to do all your algebra by hand. But if you're just like, hey, I want to just graduate and when I go to college, I want to take one math class and never take math again, then like just pass your Regents and move to the next level. But I'm going to show it the actual way now. So first up here, let me copy and paste this. I'll move this down a little bit just so I have space. All right, so I'm going to move that over here. All right, so the distributive property, that's what we're doing. So 3 times this, 3 times this, 3 times this. And here, one thing, so look out, there's a trap. Like, remember, you are the negative here. like I'm just going to say like be careful. Okay? Because when people mess up, they mess up because there's a negative here. All right, so just be on the lookout for that. All right, I'll show you how to deal with that just now. All right, so here you're going to have 3 times x squared plus 3 times 2x is 6 times x. 3 times minus 3 is minus 9. And now here, when I distribute the minus and the 4 together, so I'm distributing a negative 4. Negative 4 times 4x squared is negative 16x squared. But this is where people mess up. They only distribute the negative to the first term. They forget to distribute it to everything else. Minus 4 times minus 7 is plus 28. And there's an x, so I'm just going to tack on the x. And then minus 4 times 5 is minus 20. Okay, so if you look for the like terms here, see how you got 3x squared and minus 16x squared. That's minus 13x squared, because 3 minus 16 is negative 13. If that's math you can't do in your head, you're like, oh no, I don't like integers. Integers scare me. Then just do 3 minus 16. All right, let's be real. How many of you tomorrow, if you have to do 1 plus 1, are going to be nervous and they're going to check 1 plus 1 is still 2? It's all right. Like, don't, oh, I keep getting a syntax error. How do I fix my calculator? You're probably getting a syntax error because when you write in the y equals, your negative should be done with this sign here. Okay, so this, like negative here, is like for negative numbers. But if I want to write like 5 minus 7, I put 5. This is subtraction. Okay, if I were to write this, so let me just go to the main screen to show you. If I write 5 minus 7, that's negative 2. If I write 5 and then negative 7, this they're going to multiply 5 times negative 7. Okay, so this means negative, and this means subtract. So that's why you're getting a syntax error. How many points to pass? 26 points to pass on this Regents. Yeah, or 28 out of 86, depending on. All right, so here, now we do 6 plus 28. That's plus 34 with the x, and then minus 9. So minus 9 minus 20 is minus 29. All right, if you want to do that in your head, if you're like, oh, wait, what's minus 9 minus 20? Just remember your integer stuff. I just say negative and then 9 plus 20. Okay, and that's negative 29. So that's like how long is the video? I'm going to go as long as I can until I either finish this thing or until I get tired. So yeah, this is live. I'm actually, so hello, Rachel. Mastery is, let's see. Mastery is an 85, right? So you need 67 points out of 86. Yeah. All right. So now I will move this stuff out of the way. And now the next one, the zeros of this function. So once again, if you want to just use the calculator, just use the calculator. There's no shame in this. Okay. It's a Regents. Your goal is to just get as many right as you can. You know, it's not about showing off. You don't get style points if you do things the really like the long way. But this, you should know how to factor. Okay. But look, I just pressed graph. So y equals, I wrote x squared minus 2x minus 24. I press graph. The zeros are where the graph hits the x-axis. Now, you can see here it's 1, 2, 3, 4 to the left, and that looks like 6 to the right. If you really want to be sure, you can press second graph. See how it's 6, 0 at x equals 6, y equals 0, and at x equals negative 4, y is equal to 0. Okay, so negative 4 and 6, choice 3 is our answer, just using a graph. Okay, so once again, if you use the graph, I'll just screenshot this just so people could see. You got to know the vocabulary, because I don't think typing this in is difficult and counting the spaces is difficult. Like, that's pretty easy stuff, but knowing to do that is the hard part. 1, 2, 3. So you see how this is at negative 4 and this one here is at 6. So those are your two roots or your zeros. Okay, so zeros, roots, x-intercepts, they all mean the same thing. Yes, you could absolutely factor this. So to factor this, you're looking for two numbers that have a sum of negative 2 and multiply to negative 24. So for this, it really helps. Like, that's why like knowing your times tables is like pretty helpful for like being good at factoring. Because I look at 24 and I'm like, all right, 24. I'm like 1 times 24, 2 times 12. And I'm like, all right, 3 times 8, 4 times 6. And I think that's all of them. And then I say, though, like, all right, it's multiplying to a negative. So one of these is positive, one of them is negative, like of each of the factors, if we consider that. But then this tells me they're 2 away from each other. So right away, my like brain focuses on this because like the difference, if I talk about the difference, like 24 minus 1 is 23. 12 minus 2 is 10. 8 minus 3 is 5. And 6 minus 4 is 2. So you see how the difference, technically the difference is negative 2, but I know like the absolute value of the numbers is going to be 4 and 6. But then I have to tell myself, which one gets the negative? Because one of these is positive and one of them is negative. So the mental math that I'm doing, I'm like, all right, well, is it 4 minus 6 or is it 6 minus 4? Well, 4 minus 6 is negative 2, and that matches the middle. So this is going to be what we want. We want 4, and we want negative 6. Whereas this one would give us a middle of positive 2. So that's why, like, this one's no good. We want 4 and negative 6. So that tells us that this x squared minus 2x minus 24 is equal to 0 when we have these factors. X goes here, and now you just put the factors in. We're going to have x positive 4, and we're going to have x negative 6, like this. So we have x plus 4, x minus 6 is when the, like that's how we factor this quadratic. But a little bear trap here is some people might choose this right away and say, oh, negative 6, 4, like it's this one. But no, like be careful. That's why like multiple choice questions, people think they're easy because like you could guess. But just know, like, there is a possibility that, like, they set traps for you all the time. But the only way this will equal 0 is if one of these factors has to be 0. So, like, either x plus 4 has to equal 0 or x minus 6 would be equal to 0. And if we solve this equation, subtract 4 on both sides, x equals negative 4. And if we add 6, x equals positive 6. That's why these are our 2 solutions. Okay? So, yeah. All right, it's mostly New Yorkers here. What needs to be in pen for the graph? That's like one of those silly. I mean, for the graph, they usually let you graph in pencil just in case you mess up. But the part 2, 3, 4, they want you to do in pen, except for graphs. Okay. So at Sam, your teacher says, yeah, part 4 for sure is a marathon is a marathon of a question. So for sure we will get to something crazy like that. All right, so this is all vocabulary. If you show up knowing your vocab, box plot. So if you show up knowing the vocab here, then you'll be in good shape. Just know the anatomy of a box and whisker plot or a box plot is that this is the minimum. Okay, this value here is quartile 1. Okay, so that's Q1. This is the median. This is quartile 3. And this is the max. Okay, that's the maximum, the biggest value. So when they're like, hey, what's the third quartile? You just look and you say, oh, that lines up with 90. So choice 2. All right, like this one is easy if you know the vocabulary. If you don't know the vocabulary, then this is like kind of a nightmare. All right. Completing the square is one of the questions, and we will get there. All right. So I'm going to move a little bit quicker because let's see. We are, how long into this are we? 24 minutes in. So yeah, I'll speed up a little bit. So Joy wants to buy strawberries and raspberries. Nice. Strawberries are this much per pound, and raspberries cost this much. So, all right, I could already see she only has $10 to spend on berries. All right, so this is important. I'm going to color code this. She buys X pounds of strawberries. So strawberries cost $1.60 per pound. Okay, so that means X belongs with 160. So we need 160X, like this. So these are out because you see how they don't have the 160 with it. All right, so right away, like they screwed up the variables. So this is gone. And then they say here, raspberries are $1.75, and she buys Y pounds of raspberries. So that's going to be where the 1.75 Y comes from. But now this is the $1 million question. Is it less than or equal to grade? Like students always get confused over this. And there's a quote. All right. For my students of all grade levels, I tell them the Abraham Lincoln quote. He said something along the lines of, like now, look, I'm going to butcher it. Something along the lines of, you give me 5 hours to chop down a tree, I'm going to spend 3 hours sharpening the axe. Like meaning if you're like, oh, I'm not sure, maybe 1 or maybe 2, like I don't know, and you just pick one, think very carefully about what this means. Strawberries cost $1.60 per pound, and they're getting X pounds. And then raspberries cost $1.75 per pound, and Joy is buying Y pounds of strawberries. So this over here represents the total bill. Okay, like that's how much everything costs. But think about it. She only has $10. So if you only have $10 in your pocket, your total bill would have to be less than or equal to 10. Otherwise, they wouldn't sell you what you have in your shopping cart. Okay, like if you showed up and your total bill was more than $10 and you only have $10 in your pocket, they're going to say, nope, put something back. Unless they're like a really nice cashier and they just like say, whatever, just pretend. That's why it's choice 1. So I think people get tripped up on questions like this because they have trouble understanding what this actually means. But that's like your total bill at the register. Okay. And if you only have $10 in your pocket, your total bill better be less than or equal to, this is like what's in your pocket. Okay. So just be mindful of that. All right. So question 7, there are a few ways of doing 7. Now we have for 7, it's, let's see, we're on the main floor of some hall at a theater. All right. The number of seats per row increases at a constant rate. So this is telling me right away it's linear growth. Okay, so constant rate means linear growth. And we have Stephen counts 31 seats in row 3 and 37 seats in row 6. How many seats are in row 20? All right, so this question, there's a few ways you could do this. Now, if we look at the formula page, one thing you should do probably at the start of the Regents is go to the formula page and see like what formulas are they going to actually give you. Because, I mean, look, if you show up memorizing every single formula, then like, awesome. But for this, I'll show you what they give you. They give you unit conversions, and they give you these formulas here. Okay, so that's on your formula sheet. Now, I know I don't want to make this like too dominant so that it takes over everything, but this is going to be an arithmetic sequence. Now, me personally, I do this a different way. Okay, an arithmetic sequence just means everything's going up by the same amount. So what you would do for something like this is you say, all right, like the third row, there's 31 seats. And then by, let's see, so this is like first, second, third, fourth, fifth. By the sixth row, there's 37 seats. Okay, so 37 seats in the sixth row. Now, if you skip count here, by the common difference, this might get a little tricky. So I'm going to show this a few different ways. You're like, all right, the formula is A sub n equals A1 plus n minus 1 times D. D is the common difference. All right, like this is how much you're going up by each time. So like if I had an easy one, let's say it was like, all right, 1, 3, 5, 7, 9, 11, dot, dot, dot. Like in this case, the common difference would be 2. Because I'm adding 2 to get from one term to the next. So you see how like I'm going forward, whatever the common difference is, I'm going forward the common difference once, twice, 3 times. Okay, well think about it. Like this is something I just think about. I say, all right, well I'm going from 31 to 37. So 37 minus 31 means I'm going forward 6. But if I'm going forward 1, 2, 3 times, if I take 6 and I divide it by 3, that tells me my common difference in this case is equal to 2. Now, if I add 2, 31 plus 2 is 33, then plus 2 is 35. So you see how we found our common difference. But now if I want to go backwards, I would subtract 2. So I would have 29, 27. This represents our first term. Like this is our A sub 1 term. This is our A sub 2, A sub 3, A sub 4, A sub 5, A sub 6. Now look, they're telling you what's going on in row 20. You could sit here and add 2 like another 14 times until you get to the 20th term. Like if you want to do that, be my guest. you have a lot of time for this Regents. But it's probably better that you write a formula. AN equals A1, the first term we said is 27, plus n minus 1 times the common difference we said is 2. So if we want to know what's going on in row 20, then we're saying, all right, n equals 20 gives us a sub 20, and that's equal to 27 plus, and we would have 20 minus 1 times 2. And that's going to give us 27 plus, this is 19 times 2, which is 38, and that would give us 65. So 7 should be choice 1. Okay. So that's, I'm only showing it this way because some people requested arithmetic sequences. So that would be if like you're like, oh, I really want to use that formula for arithmetic sequences. Okay, like that's what you would do. So yeah. So let's see here. Oh, Justin, I'm glad that makes a lot of sense. Yeah, that's nice to have you on, Justin. I'm glad showing the support. So let's see. Yeah, so another way of doing this. That's not the way I would do this personally. 31 seats in row 3, 37 seats in row 6. If you really want a nice shortcut, you could go to stats, edit. Row 3 had, what was it, 31? So row 3 had 31. You could write the equation of a line between these points. And let's say you don't know how to write the equation of a line. Like you could use the calculator. Just go, all right, 6. And that's row 6 is 20. I'm sorry, row 6 was 37. Yeah, 37. We want to find out what's going on in row 20. So this, like once you have this entered, you just do stat, calculate, linear regression. Like this is if you just want to use the calculator and you don't want to think too much. And you see how it's telling you your equation is y equals 2x plus 25. So just write in 2x plus 25. Watch this magic. Okay, second graph. See, well, you're not going to have negative rows. So in the first row, there was 27, 29, 31. And now row 20 is 65. So, yeah. All right, that's a nice shortcut if you like shortcuts. Cool. So, all right. Moving on to question 8. If you fail, all right. If you fail the Regents but you pass the class, then you just have to take the Regents again at a different date. All right. But if you failed the class all year, then like, yeah, you need your credits to graduate. I think just about everywhere you need 6 math credits to graduate high school. So, yeah. Look, if you fail though, just know that there's not a whole lot you could do about it like in a moment, but just make it a goal to practice a little bit each day. You know, like when you fail a test, you really got to reflect about like why'd you fail. Think about like what you could do different, right? Because it's like kind of hard to do like a quantum leap. Like I'm gonna do my best to get you all as good as possible by tomorrow, but you know this stuff does take a little time to get good at. Like I'm only good at this because I teach it all day long and I basically been practicing it. I'm like double everybody's age just about. If you're here for Algebra 1, then I'm like more than double your age. So I've been doing this math since before everybody was born. Yeah, unless you're older. All right. Which ordered pair is not a solution? All right. So x squared minus 3x plus 4. So once again, calculator. X squared minus 3x. Now, what does it mean for it to not be a solution? It means the point is not on the curve. So if we graph this, here's our curve. And now we'd have to go through the table. So second graph, I have a feeling it's going to be is it going to be the decimal? Are they going to be cruel? Let's see. All right. Well, looking at this, 0, 4 is on the graph. So this one's out. I'll show you how to check 1.5 in a moment. 514 is on. So that's out. But notice here, negative 1, 8. Okay, so f of negative 1 is equal to 8, not 6. Okay, so negative 1, 8, this is the solution. So this is not. Because remember, this would not be a function if we had repeating x values with different y values. This would make f of x not a function. So like this is, well, by xing it, I mean like it's like not the solution, but they want the one that's not the solution. So like I shouldn't X it. I said, like, you're not the solution, but you are our answer, because we want the one that's not the solution. But like, this is a solution. This is a solution. You might be like, wait, what about this one? So this is a nice trick to know. You press, I'd pay attention to this. You press second window. You switch the table from the independent from auto to ask. And you press enter. Okay. So once again, second window, go to independent, go from auto to ask. And what that does is it wipes out your table. So now you could type in your favorite numbers like 0, y equals 4, 1.5, y is 1.75. Okay, so you could type in custom values. This is a very useful trick. Okay, for like all levels of math, when you take physics. I taught Regents physics for 2 years. These tricks are like really good for physics also. So be good at the calculator. Cool. Let me check the questions here. All right. Yeah, look, you could just plug in 1.5. Like, that's not a big deal. I'm all about like the laziest. Yeah, so if you press second graph, if it's not in the coordinates, you switch the table from auto to ask. So let's see. So question 9, we've got students were asked to name their favorite sport from basketball, soccer, or tennis. All right, here's the results. What percentage of the students chose soccer as their favorite sport? So for something like this, I don't know, it's always like my instinct to just find the total column. So total here and like just total all around. So here, if we add this, I'll try doing this without a calculator, but 2 plus 4 is 6, 4 plus 8 is 12. This will give you 9, and this will give you 9. This will give you 25. And if we add across, that looks like 120. So 42 plus 58 plus this. And then 84 plus 41 is 125 plus 5 is 130. So the total here should be 250. Okay, and if we check this column, I would just do plus 100 minus 1. So that would be 225 plus 25 is 250. Cool. Sadly, I don't have a Casio calculator, Mark. I would have to learn that one. Yeah, sorry. So, but yeah, one of these days I'm gonna if my school switches to Casio, but we're on Texas Instruments. So, what percentage of the students chose soccer as their favorite sport? Okay, well, notice how many students chose soccer. There's 99 people that like soccer. Okay, and it's of the students. So students includes boys and girls. Sometimes they'll say what percentage of the girls chose soccer, and then you would do like 58 out of 120. Okay, but we want what percentage of the students, so we're considering everybody. So that's 99 people that like soccer out of the 250 total students. Now this, I mean, I guess if I really had to do this in my head, I could, but it's not worth. I think this one, is it one? Yeah, this works out to choice 1. All right, yeah, if I had to do this in my head, but whatever, I'm not going to do this in my head because we have a calculator. Like, the Regents is not the time to flex, just get it right and move on. So let's see, 99 out of 250. And they were polite enough to make like it 0.396 that it matches this. Because if you're like, all right, well, this is 0.396, but like, why is it this? Because a percent is out of 100. So this is really like 39.6 out of 100. And if you divide by 100, that moves the decimal 2 places to the left. So that's why like this is good. All right, so choice 1. So the trinomial 3 terms can be expressed as, so this question is factor. Once again, you could put this in the y1 spot, put this in like y2, y3, y4, y5, and see which ones match. That's if you don't like factoring. If you're good at factoring, you're like, hey, I'm the best, then say what 2 numbers have a sum of -14 and a product of 49. And when I think about that, you could race me, but -7 times -7 is equal to 49, and the sum of -7 and -7 is -14. So that would give you the middle term. So that means your 2 factors, you're going to have matching factors of x minus 7 times x minus 7. And anytime you multiply something by itself, that's the same thing as writing that one thing squared. So choice 1 is going to be our solution. Cool. All right, let's see. Questions in the chat. Oh, you feel like you might pass because I'm glad, Chris. I hope you all do well, for real. I wish you all luck. I really, like, my favorite part of like teaching, like, I mean, yeah, the classroom is really awesome, but like when the students are happy that like they did well and they felt like they accomplished something, like that's just great. When the students are let down, like, I mean, I always see, like, no matter how you do though, everything like could be a learning experience. Like I've had classes that I took high school, college, probably even more so college, like if I didn't do well, it's like very easy to just be like, oh, like this didn't go well, like oh, I'm like I'm a failure. But you could react one of two ways. Like you could just stop trying altogether and just keep like not getting better at it, or you could just be the person who practices every day and get good. So completing the square is coming up, question 12. All right, so stay tuned. All right, yeah, this is June 2018. All right, so a function defined as this. Oh, okay, so we have to create one more ordered pair for the function. Which ordered pair can he add to keep it a function? So when I want something to stay a function, I'm like, the words that come to mind, I'm like, all right, function. I'm thinking like vertical line test. So like if you had like, let's say, I don't know, a circle, this is not a function. Okay, it's not a function of x. I'm not going to get into too crazy like what math turns into, because math just becomes evil like 10 levels ahead. But for algebra 1, like it's not a function because if I drew a vertical line strategically, I could touch the graph twice. So not a function. Also, you look for to determine if something is a function, repeating x values is bad. Okay, so repeating x values with different y values is bad. So here, if we look at this, like 0, 2, see how like if we were to graph these points, like there's 0, 1. So 0, 1. Let's see, did they give us nice? I guess I could, just to illustrate the point, I'll draw this out. Everything's mostly in quadrant 1 anyway, so I'll just go ahead and do this. So 0, 1 is here. We'll say that's 2, and then like 3 is like somewhere here. So that's 2, 3. We'll call that 5, and we'll say up here like this is 5, 8. And then 7, 2 will be like somewhere here. So the problem with 0, 2. So right away, why is 0, 2 bad? 0, 2 is on the same vertical line as this point. Okay, so that's why this one's out. Also, you see how like 0, 0 repeats and the y values are different. So that's why it's gone. 5, 3 is also a problem because you see like this one, I'll extend this, was 5, 8. Okay, so up here, this was 5, 8. If I were to plot the point 5, 3, the repeating x value trick is the same concept as the vertical line test. This is just more numerical and this is visual. Okay, so whichever one you like more, like use that one. But you see how like the 5 repeats twice and then you have different y values. So that's why this is gone. And also like my vertical line would hit both of those points. All right, if I was a better artist, it would have. Okay, but you see how like it fails the vertical line test. So that's why like that point is no good. 7, 0 is also bad because 7, 0, the 7s repeat and different y values. So like this is gone, and see the vertical line test, same vertical line. 1, 3 is good because the x equals 1 doesn't show up. The fact that y equals 1 is not a problem. Like there's nothing going on over here at x equals 1, so 1, 3 would not be an issue. Okay, that's why it's the answer. All right, cool. All right, question 12. This one is like going to make people sad. But once again, I want you all to like really understand that to pass the Regents, you don't have to be amazing at like every topic. This topic usually depresses people, this one. If you're going for a 9,500, then you got to be amazing at everything. Okay? So then like, yeah, be awesome at it. But like, I wouldn't stress about like small stuff. I went ahead and kept this site. Let me just see here. Do I still have this open? I do not. All right. Let me just do something real. I'm gonna stop sharing my screen just for a moment. Actually, you know what? I'm just gonna keep like rolling ahead. But basically, don't worry about the small stuff. is the theme here. I do have to, I guess, move a little bit because I do want to cover as many questions as possible. Because now we're past that point of talking about what individual things should I study? Like, we're just going to keep the ball rolling. All right, question 12. So completing the square. Completing the square, like if you're not great at it, this is what I think of. So the concept. The concept is that you want perfect square trinomials. So you want something like this. See how it's like x plus 1 times x plus 1, which is x plus 1 squared. Like this is what we want. We want something like this. So like x squared plus 4x plus 4. Yeah, that's x plus 2, x plus 2. These are what we want. All right, perfect square trinomials, these are called. Okay, so perfect square trinomials. And I'll do another one. This would be x plus 3 squared, and so on. All right, these are great. This is what we want. And this also works for subtraction in the middle. But the idea is, the reason why they call it completing the square is we're turning this x squared minus 6x, and I'm leaving a space, equals 12. We want to turn this into a perfect square trinomial. Now, the technique is you take half of the b term and square it, okay? So half the b term, like then squared, like then square, okay? So that's like what we're doing. So when I look at this and say, all right, my a term is 1. Like I have an invisible 1 in front. My b term is negative 6. So if I want to know what's the mystery number to add, the math that I'm doing in my head is I'm saying, all right, my b term is negative 6. I'm cutting that in half and I'm squaring it. And negative 3 squared is 9. So that's what I'm adding to both sides. It's called completing the square because now the left side is one of these perfect square trinomials. I know there's a minus in the middle, but that just means this is going to factor to x minus 3 times x minus 3. And this is going to be 21. Okay, so this we could just call x minus 3 squared equals 21. All right, so you see how it's in that form now. So here, p is equal to negative 3 and q is equal to 21. So they're not asking us, what makes this question annoying is they're not asking us to find roots. They're just asking us to start the process of completing the square. The reason why they made the question like this is so that you can't use a calculator. Like you have to know your stuff. All right. So here where they want the value of p would be negative 3. Okay, so 12 would be negative 3. Cool. Teachers grade the Regents. Yes. Not the multiple choice. A machine grades that. But we grade the free response. There's rubrics to follow. Just know there's usually like many teachers at a table when they grade your Regents. They used to send them to a facility. This was years ago. I've been teaching in New York City for 10 years now. But when I first started, yeah, we would all go to like a central location and they would send us tests from like other schools because their theory was like they want it to be as, no, not from, no, not someone from, it's like actual teachers that do it. AP exams get sent to a separate location, like out of state, you know. But, you know, Regents exams, your teachers score. I could score AP exams. I just, I would have to travel and I don't want to leave my family for a few days because like my kids are little. Like, you know, I can't be gone for too long, but like when they're older and stuff, like I'll probably wind up, like, I don't know. It might be a good experience for me to grade AP test. So, all right. Let's see. Moving on. So, which of the quadratic functions below has the smallest minimum value? So here I'm thinking vertex. Okay, smallest minimum value. They're talking about the y value also. Okay, so which one has the lowest low point? So this one is nice because it's drawn out. You just have to look. So you see how here, there's the vertex. And you just have to be able to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one has a minimum y value of negative 10. So you see how here, like y equals negative 10, that's our lowest point. So our lowest y value. So if anything could beat this, then great. Now this one, the other two, just know this. Oh, well, yeah, good night to anybody going to sleep and good luck tomorrow. All right. I hope you on your way to doing well, or, to whatever score you're hoping for. Thanks for stopping by. So x squared plus 2x, and then minus 6. So you press graph, and there it is. Now, if you have good eyesight, you just say 1, 2, 3, 4, 5, 6, 7. All right. If you're like doubtful, oh wait, second window, go back to auto, so the table is normal. And yeah, it looks like -7 was the turning point. You see how here the table kind of centers around -1, -7 here. So choice 1 has a minimum y value of y equals -7. X plus 5, x plus 2, on the other hand, things are a little different. So now I would just clear this. X plus 5 times x plus 2. Whoops, pressed enter, didn't mean to. All right, so x plus 5, x plus 2. This one is a decimal, so like, how do I do decimals? You could press second trace minimum. Second trace minimum. I like to go a little before, enter, a little after, enter a third time. -3.5, y equals -2.25. If you want, this is also optional, x squared plus 7x plus 10. You might know this formula, x equals -b over 2a. All right, that's to find the axis of symmetry, which tells you where the vertex is. So here, a equals 1, b equals 7, c equals 10. You could also do it this way, but this is like more painful. -7 over 2 times 1, x equals -3.5. And if we remember, see how when x was -3.5, that's our x value, y is -2.25. So you could also use the formula. So that works too. You will be able to view this live after it ends. I will keep this going. Yeah. All right, now the last one here, this one I could see the vertex, like the minimum is at -6. So y equals -6. So which one's the smallest? This is the smallest, -10. Oof, 2 Regents. I'm impressed at everybody here. Yeah, it's a lot. It's was it the English Regents was today, right? ELA, and then like one of the, was it living environment or something? I forget. All right. So which situation is not linear? Okay, linear is constant rate of change. I'm going to abbreviate rate of change like this, rate of change. So membership fee of $10 down. So this is like our B value. If I think of this formula, y equals mx plus b, the fixed amount is your B value. And the rate, $10 per month, is your slope. So this could be modeled with 10x plus 10. So this is linear. So it's out. 250 initially, that's our B value. And then $3 per mile is our slope. So this would be like y equals 3x plus 2.5. So also linear. An employee earns $12.50 per hour, a restaurant employee. So that's y equals 12.5 times x, also linear. So whatever this is has to be the answer. But this one, all right, there it is. A $12,000 car depreciates at a rate of 15% per year. So this would be exponential. Okay? So this, this, let me see. Wait, this formula, is it A? Oh, this one. This formula. Okay. So here, if we had to write a formula for it, they're not telling us to write a formula, but why not? Like our principal is the initial amount. So P would be, like this would be the P value. And then R would be 15%, which is 15 out of 100, which is 0.15. Depreciates means when you buy a car, well, especially with a car, the moment you buy the car, it loses value, sadly. The moment you drive it out the lot, it is not worth the same because you already drove it, So 1 minus 0.15 would be 0.85 to the t. So that would actually be our formula to calculate the value. They're working on abolishing Regents. Who said that? Oh, no. I mean, I guess that would be, I don't know. That's like, I guess, a mixed bag. I am going to do an Algebra 2 Regents review, indeed. And I am also going to do a Geometry Regents review. So it's all happening. I'm just, I also do live streams for AP Calculus. So I did a live stream for the AP Calculus exam. At one point, I had like 900 people on. Do I accept bribes? No, speech guys. Sadly, no, because I have to do this job for another 30 years, and yeah, I mean, maybe if it was like $5 billion or something, yeah, but no, thanks for the offer, but your best bet is to just study for this thing and do your best, and whatever happens, just learn. So, all right, I'll take like a little, I guess, pause to talk to people in the chat. I do play guitar, yes. So at Justin Zaffron, I do play guitar. Little rusty, but it is fun. Calculator tricks for sure. Now, colleges, so look, colleges don't care about Regents. Like, sure, and I'll euphemize it. I'm not going to say what was actually written. Colleges don't care about the Regents, but they care like how good you are at math. So the biggest mistake is like for like New York high schoolers, because I've been teaching in a high school now for 10 years. Like I know the deal. I taught at a college briefly. The thing is, to graduate high school, you need like all right, was it like Algebra 1, like Regents, like 65, which we saw before. It's like 30% of the test. Like once you get that, like cool, now I could graduate. But the problem is like if you go into college and like that's all you know, and you go to a college level math class, they're not going to let you get by with 30%. So there is currently like a pretty decent gap between the graduation rates and the college readiness rates. So if your goal is to just graduate high school and then people are, oh, I don't want to go to college, then then all you got to do is graduate. But if you want to go to college and be okay with math classes there, like you should show up knowing some algebra for sure. So the Regents, it's like a silly test. I mean, it's like arbitrary. It's like, all right, it's just a random test. But you being good at it will help you out later for sure. That's my 2 cents on the Regents exams. All right. Or you could just be the next Mr. Beast. That works too. So 15-kilometer race. Sarah signed up and she's doing training runs. Which runs are at least... Oh, so we got to convert here. All right, so this one's kind of painful. All right. Formula sheet, because I don't have these memorized. The only one I do know is that there's like 5,280 feet in a mile. That's about it. That's all I got. All right. So if you have these memorized, then like awesome. Otherwise, this is what you need. So 10 miles to kilometers. Oh, so here we go. This is important. 1 mile is 1.609 kilometers. So 10 miles, you could set up a proportion. Like some people might rather do it like this, like, 10 miles over X kilometers equals, and then they say like 1 mile over this, and then they cross multiply. Like you could do all that, but that's going to be a lot of work for later. So I do it a different way. And I think you should start doing it this way too. Is like, 10 miles, I'm going to multiply by 1.609 kilometers over 1 mile. So the reason why this is okay to do is because these are equal. 1.609 kilometers is equal to a mile. And when you have equal things on top and bottom, the fraction is equal to 1. So miles cancels. And if you do 10 times 1.609, that's 16.09 kilometers. So this is 16.09 kilometers. So which of these runs are at least 15 kilometers? Well, this is at least 15. So this one's good, which means this is out and this is out. So let's say like you can't do the rest of this. Like you just being able to eliminate stuff is going to be like really helpful. All right. I'm just making sure my key is nearby just in case I have like a lapse in judgment. All right. So moving on here, 44,880 feet. So for this one, what you got to do first is you have to convert it to miles. So we say 1 mile equals 5,280 feet. Okay, so that's from our reference sheet. And what I'm going to do is I'm going to multiply by 1 mile over 5,280 feet. These are equal, so I could do that. Like 1 mile over this, these are equal quantities, so it's fine to do this. But now I'm in miles. I want to be in kilometers, so I'm going to use this one again. I'm going to do now times 1.609 kilometers over 1 mile. And now these units cancel. So I have to do this. I have to do this number times this number divided by this number. Okay, like that's what I'm going to tell the calculator. So back to the main screen. So we're going 44880 times 1.609. And then all of this, just divide by 5,280. And then drum roll, we get I'll just say 13.7. Okay, so 13.7 kilometers, which is not 15. Okay, it's less than 15. We need it to be at least 15. So it needs to be like, we need our answer to be greater than or equal to 15. So that's why 2 is out. And now yards. Well, we could go right from yards to miles. 1 mile is 1,760 yards. Okay, so for this one, I'll just do this one right here directly. If we multiply by 1 mile, so 1 mile over 1,760 yards, and then multiply by, I'm going to erase this now that we took care of this. I'll get that out of the way. If we multiply this one, now we want kilometers, by the first one again, 1.609 kilometers over 1 mile. You know you're doing this right when the units cancel. See, like yards over yards cancels, mile over mile cancels. So now, once again, calculator, and let's see. So we got 15560 times 1.609, and we're dividing by 1760. I could just do that in one shot, like over 1760. Okay, and you get 14.22. Another cool trick, press alpha, y equals, enter. And you could just make a blank fraction. 15560 times 1.609. This is if you're like scared of order of operations and your parenthesis game is not strong with the calculator, then this will save you. All right, 14.2. So this is 14.2, which is definitely not at least 15. So this one's out. One only. All right, let's see in the chat. How's everybody doing? All right. Oh, wow, we got 170 viewers. We had 900 something total. This is so cool. My videos from 10 years ago. Wow, Dark King, thank you. That really means a lot. When I look at my oldest videos, I don't want to say, oh, I cringe a bit, but my first videos were when I was living at home, and my first camera was like basically a baked potato. So I had a $100 camera in my in my old bedroom, and I had a whiteboard on my wall, and that's how I got started on YouTube. Which I'm glad though, because like the key is if you want to get like started on YouTube, if anyone's like thinking of doing YouTube when they're older or even right now, you want to take Mr. Beast's path, the key is like just get started and always ask yourself, how could I make the videos better? And little by little, like you just get better. Like you just got to put your time in. What happens if you get 100 on every Regents exam? All right, so Fortnite Sweaty Kid, that's a great username too. If you get 100 on every Regents exam, you get to write a book. And you could say how to get 100 on every Regents exam. And you could give the worst advice in the world, and people will have to buy that book and follow it. You could say like, oh, just like, eat like a cup of ketchup before each Regents, and like, like do like 10 jumping jacks and you'll get 100. Like you could just make anything up, and people will have to go along with it because you got 100 on every Regents. So yeah, that's your prize. I don't know of many people who have gotten 100 on everything. I have students in the past who have gotten 100 on algebra. Let's see. Would that affect your... I'll tell you this. If you could get 100 on every Regents, like you're probably going to get into like some of the best colleges. So yeah, being a really good test taker, like for sure will be great for you. All right, if I fail the Regents I'm taking now in 8th grade, is geometry bad in high school? Geometry, like I wouldn't say any part of math is like terrible, at least for high school. Like math gets really hard at some point that like nobody could do it when you get to like beyond college level math. But if you put the work in, it's doable. The problem with math is like if you fall behind and then you stop trying, it's not like, all right, well, I'll just get them next week. It just gets worse. It gets worse and worse. And it's then you like, oh, algebra 1 was bad. Well, have fun in algebra 2. Like they're just going to put you in algebra 2 and then you're just going to be like, oh, that doesn't mean there's no hope for you. But that means you're going to have to like build your foundation up and then learn the new stuff. So you're just going to have more work ahead of you. AP classes or IB classes. I don't know too much about IB classes, but AP classes are like pretty solid. This year, I don't know what the curve is. We always know after the fact, but it's usually around like a 26 to a 28 raw score, which is like 13 to 14 multiple choice questions correct. The benefit of taking Regents in 8th grade, that I would just say is if you want to go on an accelerated path, like there are students that love taking AP classes and they wind up, I've had a few students in the past graduate early. Like they graduated after their junior year because they just got all their credits done. So, I mean, if you just want to overload, like some people, they wanted to graduate high school in 3 years, college in 3 years, they just want to get to the workforce right away, then that would be the advantage. The highest level of math you could take in high school, I know one professor that I had, his son was a math prodigy. At 5 years old, like when he was around 5, so he was 5 years old, he was doing calculus. According to legend, by the time he was 13, so he was 13 years old, he was taking graduate level math. So graduate, like, why can't I write anymore? Graduate level math. This is at SUNY Binghamton. So he was like 13 years old. Like that's like after like your 4 years of college, there's graduate level, and he was just destroying everybody. But his dad was a math professor. His mom was like a chem professor. So like he just like got, but he was like, he had like some special gifts. Not many people are born with that ability. Like he was like really just accelerated, like no joke. So he still had to graduate high school, but his dad had him enrolled in all these advanced classes. And then like he did his PhD at like Princeton or something in mathematics. So yeah, he was a chess master. He won like the US like junior chess championship when he was like 12 or 13 years old. So that's one cool thing about college is like when you go to that math community, you see like, oh wow, like the sky is the limit. There's so many levels to this. Like you could get 100 on every Regents like we were talking about before. But then there were like people that are like in that next level up. Like there's always like someone at the next level for sure. Unless you're the best in the world, then like you're at the top. But I'm most certainly not near the top. I don't know why I erased this. My interest was more in like teaching. I didn't want to go for the next level graduate in math because it's kind of like a time and money thing. Like I'm still interested in math, but I also enjoy like time with people. When you're a professor, there's more of an emphasis on you researching by yourself, but I do enjoy the time, with students. All right. Let's see. So here, I would draw this. The range is like possible y values. So possible y values. All right. So for this, if we draw it out, x squared plus 2 is going to look something like this. Okay. So there's x squared plus 2. The y values here, I also think of like the concept I think of is like walls. That's for like domain. I think of walls. And for the range, I think of the floor and the ceiling. Now here, there's definitely a floor. It's like, oh, the floor would go at 2. So, and 2 is included in my floor. See how it's like a solid point here? So 2 is included in my floor. But where's my ceiling? I can't have a ceiling because this quadratic is going to keep pushing my ceiling up. So that's why there's going to be an infinity here. 2 to infinity, choice 3. Okay. Now, if they wanted to know, this choice here would be our domain. Okay, because I can't put walls on this. You see how like if I go to put a wall here, like this thing is just moving like out and out and out. It would just keep pushing this wall this way. So I can't put a wall. And if I can't put a wall up, it's like plus or minus infinity. Okay, so yeah, that one is choice 3. All right, let's see. Fixing the mic here. I'm trying to keep the gain at a certain level here because let's see what time. We are at 8:40. Okay. Yeah, my kids are like just about to pass out, and then I'll be able to just talk through. All right, so the amount of money Mike gets paid weekly could be represented by this expression here. All right, so here we go. We have a linear. Yeah, he's not happy about going to sleep. All right. It's strange because then you get old and you just, like, that's all you want to do is sleep. It's like, oh, the idea of having 8 hours of sleep is just magical. But I'm ways away from that. All right, so 250A plus 290. So this is how, let's see. Blah, 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 blah. Oh, all right, so this is his, like, how much he's getting paid weekly. So just know when you have y equals mx plus b word problems, this is the rate. Okay, so the rate of change. And b is your fixed amount. Okay, so when I look at this, like 250A plus 290, like I don't even read this like that closely. I'm just like, I know this is the fixed amount. So 290 is the amount he's guaranteed to be paid. So right away, like looking at 17, like choice 3 is jumping out at me. But let's also think about like, why are the wrong answers wrong? Why are the other answers no good? 250A is the amount he's guaranteed to be paid each week is not good, okay? 2.5A is the amount he earns when he sells A accessories. So let's just see. The slope is always the rate of change. Yes. I'm just like following the chat here, like alongside. So what they're saying here is, once again, what is the constant term in this expression and what does it represent? So the constant is the one without the variable. This is the variable term. Like this one is technically true, but this is the variable term. Okay, so this one has the variable a. So like that's why like 2 is a good answer because it's true and correct, but it's not the constant term. Like they were specifically asking for the constant term. So just make sure you're reading carefully on stuff like this. All right. So moving on. 18. So we have a graph of a cubic function. Cubic just means it's going to have like an x to the third plus blah, blah, blah. Like that's the highest power. Okay, so the highest power is going to be x to the third. So then here, the trick to this. So there is a trick. So what I look for in questions like this is that roots and factors are opposites. Okay, so roots and factors are opposites. Okay, so this is a really big idea, and just know this will help you at some point of the Regents. Okay, so let me just fix this, get the audio back. Yeah, I lowered the gain a bit here so that my kid doesn't make too much noise because he's protesting a little, doesn't want to go to sleep. So roots and factors are opposites. So when I look at this, I say, all right, my roots are going to be x equals, and let's see, we have negative 1, 2, 3. So negative 3, negative 1, and 1. So negative 3, negative 1, and 1 like this. So those are my roots. Now, if I'm not careful, I would fall in this trap and say, ooh, choice 1, minus 3, minus 1, 1. But remember, roots and factors are opposites. So I would want factors that have x instead of minus 3, plus 3. Instead of minus 1, I would want plus 1. And instead of positive 1, I want minus 1. So now I scan the answer choices, and you see we have x plus 3, x plus 1, x minus 1. Choice 2 is going to be our solution. Yeah, my kid is not pleased. He will pass out soon, though. Please, I'm going to fail. Oh, I think he's the crying emoji right now. All right. He's my live crying emoji. Yeah. All right. So let's see. Let's see here. Moving on. So question 19. All right. Question 19. Mrs. Allard asked her students to identify which of the polynomials, blah, blah, blah. Okay. So which polynomials are in standard form? That means highest power of x to least power. Okay, so from greatest to lowest power. Okay, so greatest to lowest power. That's what we want. So here, this one's no good. Because you see how it's 4, 1, 2. Like, 1 is not greater than 2. Like, what would be better is if we said this. 15x to the 4 plus 3x squared minus 6x minus 1. Okay, that would be good, but that's not what they wrote, so this is no good. This one is fine, because you see how it's like power 3, power 1, constant. This one's good. This one is also good. Power 5, power 2, power 1. So which student's response is correct here? So let's see. Looking at this. Oh, okay, so they gave them names. I'm like, wait, why is it Tyler, Susan, Fred, Alyssa? So 2 and 3. All right, so 19 is going to be choice 3. Yeah, I just got thrown off by Fred and Susan, and I'm like, wait, why? When did they come in? When did they join the party? But they are part of the mix. All right. All right, let's see. Oh, yeah, mostly New York here. I would imagine so. I mean, some people might just join for some regular algebra review. Cali, I don't know if Cali is done early. I know there's a lot of states that are done in May, so we go longer. Oh, nice, the Bronx, New York. I'm just glad I'm like reaching all the boroughs and stuff. It's good to know that this is traveling far. All right. Am I a sports fan? Yes. I haven't watched sports in a while because like now I'm in like full-time dad mode, so I watch a lot of Disney Plus and that kind of stuff. But I do when I used to watch sports a lot. I like the Yankees. I like the Giants. And I didn't watch a ton of basketball. Like I respect the sport. It's like very impressive. Like all the professional athletes like amaze me. But I really watched baseball and football the most. But I mean, basketball I would just say the Knicks, like because I just like to root for the New York teams. Yeah. The other states have different exams. Like in Texas, they're called the STAR exams. Like this is the Texas exam is STAR. I think they spell it like strangely too. I guess like the star is their logo, so they named it STAR. So yeah. Yeah, so New York State entirely. Anybody like from upstate New York here in the chat? Oh, we got one from Buffalo. How cool. See, I like knowing these videos are traveling far. Westchester, how awesome. Let's see. Oh, Staten Islanders too. Yeah, the school I teach at is a Staten Island school. I am a Staten Islander myself. So shout out to the SI crew. So I'll get the ball rolling here. I guess I should, how much? Oh, we're at an hour and 20. All right. So yeah, I'm going to just power on through here because it's getting late, but it's nice to connect with everybody too. And if you haven't subscribed, anybody, if you are, enjoying the live stream and you're finding this helpful, like definitely, hit that subscribe button. I will be doing this for geometry for you next year. If you want to join for geometry, I really do enjoy doing these. I enjoy building the community. My goal is to just keep upping like my numbers, like setting the bar higher each year is my goal. I like knowing that I'm reaching Queens. Awesome. I love Queens. My wife is originally from Queens. I went there to visit plenty of times, like before we were married and stuff. And the Chinatown in Flushing is like really awesome. So, yeah. Oh, thank you for subscribing. Anyone who pressed subscribe. Oh wow, yeah. Now it's rolling. All right, it's totally moving. So thank you all for helping out. So which graph does not represent a function that is always increasing over the entire interval from -2 to 2. So we want something that's not always increasing. So right away we could eliminate something like this. Like this one's out because this is always increasing, like from -infinity to infinity. This thing is always increasing. Okay, because it's a line and it has a constant rate of change and the slope is positive, so it's just constantly going up. Okay, so 1 is like the easiest one I would say to eliminate. But then you look at this and say, all right, well, this one goes up and then goes down. So it seems like, it could be a little confusing here as to which one are we going to actually go with. So we got to think about this very carefully. we're on the interval from -2 to +2. So I'm going to zoom in a little bit. Okay, -2 to positive. We want something that is not. So which graph does not represent a function that is always increasing over this entire interval? So right away, this one's looking good because you see it goes up and it goes down. So I like this one. But one of my students that I remember did amazingly well on so many Regents. On their AP exams, they got all 5s. And I remember asking the student, what was your secret? How did you do so well? How did you get like over 95 on every Regents and 5s on all your AP tests, like AP Physics C, AP Calculus A, B, B, C, like everything? And the student told me that they also check why the wrong answers are wrong. So if we look at choice 2, you see why this is no good? Because from -2 to 2, we're going along this part of the graph. See how it's always increasing from -2 to 2. So that's why this one's out. And then here, -2 to 2, see how here, just this portion of the graph is always increasing. Yes, it starts to decrease here. So some people like, this is a trap, okay? A very dangerous bear trap. But, oh, my sound up. Yeah, now my kid is asleep. Is that much better? You could all hear me much better now at NASMA. Yeah, I was waiting for my kid to fall asleep because he was like crying really loud. And I didn't want to have that go through people's headphones. So yeah, but this is a trap because you see how like the turning point happens around x equals 3. Okay, but we're only concerned with the window from -2 to 2. Okay, so now this, yeah, is out. Yeah, look, this is the one challenge. Like maybe someday the channel becomes huge and I could buy a massive house and I could get a YouTube studio where I could, be soundproofed and far away. So, but now my kids are asleep and we should be good. All right. Oh, and thank you for the subscribers. Wow, the numbers are absolutely flying up. Choice 3 is the answer to this one. Okay. So here, looking at this one, ice cream shop, the profit P of C is modeled by the function P of C equals this, where C is the number of ice cream cones sold. An appropriate domain for this function is, all right, think, this is all thought experiment. This is that quote I said before. If you've been here for the whole time, you give me 5 hours to chop down a tree, I'm going to spend 3 hours sharpening the axe. That means think about it. Okay, C is ice cream cones. Okay, so C is ice cream cones. If you went into an ice cream shop, would they give you a rational amount of ice cream cones? Like to say, all right, I ordered an ice cream cone. And if I think about it here, like let's say like this is a rational number, like 3/37. But if someone gave you, I'm going to lower it just a little bit, the gain. So I'll talk a little bit louder. They wouldn't sell you this many ice cream cones. Like that would just be like, this is totally insane. Okay. No one would ever sell you that much ice cream. All right. There's no way like to really measure that accurately, consistently. Okay. So rational number is out. So it would have to be an integer because these are whole numbers. Okay. But what is the only one that makes sense? Positive integers. Okay. They're not going to sell you negative ice cream cones. Like you went into an ice cream store. Let's say you go to Carvel or Cold Stone, and you're like, hey, can I get like a chocolate cone? And they're like, all right, here's -5 ice cream cones. That means you got to give them ice cream. That place would go out of business very quickly if instead of selling you ice cream, they just demanded you make them ice cream. Like that just doesn't make sense. So it has to be positive integers. Okay. So yeah. All right, cool. How many real number solutions does this have? Calculator. Oh, finally, we get to do something like the easier way. All right. So y equals, just punch in 4x squared. So you got 4x squared plus 2x plus 5. Okay, press graph. Notice this does not hit the x-axis. Okay, this does not, I repeat, hit the x-axis, which means that it has no solutions. Okay, it would only have imaginary solutions, which you don't do until Algebra 2. So this one has 0 solutions. Another way to do this, A equals 4, B equals 2, C equals 5. You could use the quadratic formula. Okay, so you use this one. The problem is when you go to use the quadratic formula, this part under the square root is going to come out negative. All right. And if I use the calculator on that part, so I'll just show that. I'll show that part on the main screen. If I were to do square root of, and just don't fall in this trap. Well, b is not negative, so we're not going to have an issue there. But I'm going to have 2 squared. So 2 squared minus 4 times a is 4 times c is 5. And when I go to do this, they're like non-real answer. And that's because the part under the square root, we call that the discriminant, which I don't know if they teach it that way just yet, so just potentially ignore that. So minus 4 times 5, like this part, is negative. Okay, and you can't take the square roots of negatives when you're looking for real number solutions. Okay, so there are no real solutions, 0 solutions. All right, students were asked to write a formula for the length of a rectangle by using the formula for perimeter. Here's the 3 responses. Which responses are correct? So you want a formula for L. So solving for L, do minus 2w. So these questions usually depress people because nothing really simplifies. Like p minus 2w is just p minus 2w equals 2 times L. So now I would just divide by 2 on both sides. And that tells me L equals p minus 2w over 2. Right away, this is looking good. Now, the next thing here, this is also looking good. Looking at this one, I like this answer. Now, this is all about how good are you at fractions. If you're good at fractions, you'll know that like 5 over 7 is the same thing as like 1 over 7 times 5. Like you could take fractions and stretch them with multiplication. So this is the same thing as 1/2 times p minus 2w, like this. Okay, so just know like this is legitimate. Okay, like this is something you're allowed to do. All right, because once again, I could always call this like p minus 2w over 1. And if I do 1 times p minus 2w, that's going to give me this over 2 times 1. So like that's how I know it's good. So that tells me, looking at this, it looks like choice 2 is also good. All right, that's the 1/2 times p minus 2w. And now the last one to check is the first one. If I distribute this, I'd have 1/2 p minus 1/2 times 2w. Like if I do that on the side, 1/2 times 2w, half of 2 is 1. It would just give me minus w, which gives me the first one. So they're all correct. Okay, all of them are correct. So yeah. All right, this is a recursive sequence. So there's a way to do this in the calculator, but it's like probably better to just do this by hand because the calculator is like a real mess to show. So a1 equals 1. And then we want to find a5. So just know, like, when I see a sub n minus 1, that's the previous term. That's how I think of that. That's the previous term. So if I'm talking about a2 equals, and notice that's like when I plug in n equals 2. If I plug in n equals 2, I'm going to get a sub 2 equals n equals 2 times, and I think of this as the term before. The term before was 1. All right, so like I know this is eventually just going to be like 2 times the term before it was 1, which is going to be 2. But I'll go through the process anyway. So this, like what I'm thinking of is when I want to plug n equals 2 into a sub n minus 1, that's a sub 2 minus 1, which is a sub 1. So that would give me a sub 1 like this. And now, once again, a sub 1 is equal to 1. So that would give me 2 times 1 equals 2. And then n equals 3 would tell me, I plug in n equals 3, I get a sub 3 equals n equals 3 times a sub n minus 1 is the previous term, and the previous term we found was 2. So I could do it that way, or I could say a sub, and if I plug in 3, just imagine here 3 minus 1 would give me a sub 2. And we just found a sub 2 is equal to 2, so 3 times 2 is equal to 6. And then n equals 4, plug in, gives you a sub 4 equals 4 times the term before was a sub 3, which is going to give us 4 times 6, which is 24. And now the last one, n equals 5. That's the one we want to tell us a sub 5 is going to be n, in this case is 5, times the term before was a sub 4. And 5 times 24 is 120. So choice 3. Okay. That's a hard question. I don't know. Recursive sequences could be a little tricky. Like this notation, like this can be confusing. Okay, I would say that's a little confusing, but just know like this is big. When you see a sub n minus 1, that's the previous term. All right, and you just got to practice. You'll get better at this stuff. Right. So moving on to the part 2s. This is all calculator, this question. So graph this. So calculator, and let's see. We got y equals square root of x plus 2. And I don't know what I just pressed. Let's try again. Square root of x plus 2. And we're going from -2 to 7. So I'm just going to press zoom 6. So here's our graph. But we just need from -2 to 7. So first thing like I would be thinking about, and be mindful, these are only 2 points. So your answers like don't need like a ton for full credit, but they need some precision here. So I would go to the graph, and then I'd go to the table. Second graph, here's my table. And we're going from -2 to 7. So you see, like there's -2 and there's 7. So I just need these values. Me personally, I tell my students, show, like don't go overboard showing work, but show some work. Like me personally, like what I would write down, I would say like, all right, x, f of x. And I would say -2 is good because it's a whole number. -2, 0. -1, 1. 2, 2. And then 7, 3. Please don't try to graph 2.2361. Don't get out your magnifying glass at the Regents, or your proctor will laugh at you. All right, like keep it reasonable. All right, don't go outside this window. If you get excited and you're like, cool, ready, set, go, like you're getting nothing. All right, so make sure you follow directions. Like -2, 0 is here. Okay, then -1, 1. That's this point. 2, 2, so over 2, up 2. And then over, you're just going to be able to count to 7. I would struggle with that. Let's see. So 1, 2, 3, 4, 5, 6, 7. All right, over 7, up 1, 2, 3. Okay, and you just connect these. Okay, see, this means stay between x equals -2 and x equals 7. Don't write that on the Regents, but that's what it's telling you to do. Okay, if you do this, this is a trap. Okay, don't do that. This is wrong. Okay, that would be if they said x is greater than or equal to -2. Then you do that. But they didn't tell you to do that. So stop at this point. Okay, is what you do. That will get you full credit. All right, you don't have to go like too crazy here, like anything more. I mean, this, yeah, once again, the table is really good, and labeling the graph like this is fine. I mean, if you want to label the y-axis too, like 1, 2, 3, like that's okay. Cool. All right. And yeah, just anyone who's just joining here, oh wow, the subscribers are flying in. Anyone, if you have not subscribed and you're happy with this live stream here, and you, I don't know, plan on coming back for geometry next year, or just Regents videos in general, please, yeah, feel free to subscribe and join the fun. All right, so moving on here. Let's see. Caleb claims the ordered pairs are from a nonlinear function. Okay, state if Caleb is correct, and then we have to explain our reasoning. Okay, so this means we have to write a sentence, but be mindful, this is only 2 points. So nonlinear means that the rate of change is not constant. Okay, so this is like what I'm thinking of is non-constant rate of change. So just looking at this, I'm like, all right, up 2, over 1, up 4. All right, so here you go. See how it's going like +2, +1, and then +4, +1. So there's this is the problem right here, like this part, the +4. All right, so Caleb is correct. So if you just say like Caleb is correct, they might just, let me just see if they throw you a point for that. Do they say yes? Let's see, 26. I don't know if you, Oh, no, if you just say correct, but let's see, yes, but no. Oh, okay. If you just guess, if you just say, if Caleb is correct, if you just say yes and you guess right, 1 point out of 2. They're very forgiving on this Regents. All right, but if you want like actual value, then you have to explain more. So looking at this, you could just like do the work. You could say, all right, like slope, here's the slope formula, y2 minus y1 over x2 minus x1. And you could do the slope formula, twice. Like you could find like the slope, like let's see, 0, 2 is 1.1428. And if you find the slope, let's say you find one slope here, 4 minus 2. So this minus this over 1 minus 0 is 2. So there's one slope. And then you find another slope between these 2 points. So m equals 8 minus 4 over 2 minus 1 is equal to 4. That is your evidence that you could say, is Caleb correct? You could say Caleb, or I would say yes, like yes, Caleb is correct. Because f of x does not have a constant rate of change. Okay, it does not have a constant rate of change. Okay, and you can abbreviate rate of change, capital ROC. And that's good. There's only 2 points. So please don't write like an entire story like about go on like wacky tangents. Like just answer it and move on. And like you should be good. All right, this one's solve for x. Now I'm looking at the rubrics here. I don't think here that we have to, they didn't tell us to do this algebraically. So could we just get away with graphing this? I think here we could use a graphing calculator, but you know what, to be honest, this one I would rather just use the quadratic formula because their chances are they're going to tell you solve this equation algebraically. Oh, whoops, this got moved a little bit. So let's see, a equals 1, b equals 1. So see how it's like it's 1, 1, and c equals -5. And remember, x equals negative b plus or minus square root b squared minus 4ac all over 2a. That's on the back page too, on the formula sheet. So x equals, here we go, negative b is 1 plus or minus, and we have b squared minus 4 times 1 times -5 all over. So all of that divided by 2 times a is 1. So x equals -1 plus or minus, and this gives us 1 plus 20. Now look, you're not going to gain anything here by like, once again, flexing and doing all this math in your head. If you want to show this work off to this, like do this in the calculator, 1 minus 4 times 1 times -5, like it's going to be 21. But, use a calculator if you have to. So square root of 21 over 2. So just know this gives you 2x solutions, -1 plus square root of 21 over 2, and x equals -1 minus square root of 21 over 2. But let's say if you stop here, you're only going to get partial credit because they actually want you to type this in the calculator and round to the nearest 10th. So they're giving you a little bit more to do. So here, that's where I would press alpha y equals enter and go -1 plus square root 21, and then you're dividing by 2. So you do this, enter, and then a little trick. Go here, press enter again, and then go to the plus sign and just make it a minus. And that gives you both answers. All right, so I'm just going to copy and paste this. Now, one thing you want to be careful of. I see students mess this up all the time. All right, please be careful. Some students will type it in like this. They're going to go, all right, -1 plus square root 21 divided by 2. All right, so they're going to go like this. The problem with this, you're like, wait a minute, I didn't get the same answer. My calculator's broken. It's like, no, your calculator's not broken. You're broken. No, you're not broken. But you have to write -1 plus radical 21 in parentheses and then divide by 2. And you see how then it'll give you 1.8? All right, so just be careful typing. I've seen plenty of students, even in calculus, mess excuse me, water break, mess up questions because they just typed it in wrong. Sorry, I've been talking for a long time. And allergy season is pretty rough. All right, so let's see. So that tells us x equals 1.8 and x equals negative 2.8. All right, now let's say for the people that just want to pass, if you're looking at this like, wait, I don't want to do that myself, then just write x squared plus x minus 5. And what you do here, I'll make this bigger. You press graph, you want the roots. So press second trace number 2 for the 0. And you go you go up to the 0, you press enter once, press enter twice after the root, enter a third time, you see you get negative 2.8. So if you do this with no work shown, so I'm going to put the rubric on the page. So if you find the 2 roots just by tracing, and you know how to round, but you, like I said, you don't know how to do the algebra. So let me cut this and put this here, just so you could see I'm not making this up. And that was a fail. So let's try one more time. How about, hang on, I will get it. Let's try it one more time. All right. There we go. This is like, kind of rigs the test a little bit. Okay, especially this part. No work shown. Doesn't matter. You still get a point. Okay, so if they tell you do this algebraically, then do it any way you want and get a point. If like, it's better to get 1 than to get nothing. So just think about that. All right, moving on. This one, know your rules. If you forget the rule, all right, not that this is the same function, but like if you're like, oh no, what happens when I replace the function's x with x plus 2? Most common mistake is people say, oh, it's going to go to the right one. I'm sorry, the right 2, but it's actually going to go to the left 2. Like, let's say I had like, I don't know, like negative x squared plus 5. So that's what it looks like. But if I replace the x part, if I replace that with x plus 2 and go like this squared and then just replace the x with plus 2, see how it moves it to the left 2 units. Okay, so 2 units left. The original was blue, the new one is red. Okay, so that's like how you could kind of reteach yourself. So this is going to go left 2. Instead of to the right 2, it's going left 2. All right, so that means we're going to go 2 this way. I look for other points, like this one's going to go 2 this way. This is going to, this one here is going to go 2, and this one is going to go 1, 2. Wait, can I count? 1, 2, like this. All right, so now I just connect these. Let's do a better job of connecting those. So here like this. I mean, maybe do like one more. Like I would just do these then, just to be like extra safe. I mean, it's not, I wouldn't say it's like, yeah, I mean, I guess do as many as you can. It doesn't take that much more time, so let's make that neater. Yeah, this is much easier without a writing tablet, like if I had actual paper. All right, cool. So there it is. And on the same set of axis, you know, sketch the function. And I would just say like that every point moves. Yeah, so the points move 2 units left. Okay, just in case they're like, wait, how did you draw that? Like you're just saying, hey, the points move 2 units left. Sorry, end of the day, I'm getting fried. All right, oh, this one's nice, but we got to determine algebraically. That doesn't mean we can't use a calculator though to get us the answer ahead of time. So now there's an apple and it's falling out of a tower, 256. Wow, that's a big drop for an apple. Hope that doesn't hit anybody. That would be very painful. All right, negative 16 x squared. Doesn't matter that it says t. You could use x. Plus 256. So you press graph, and there it is. All right, now if you want a good picture here, see how this goes up to 256. Go to window. You can make the y maximum. Let's say I made it like 275. So you see there it is. The thing is though, this apple wasn't thrown, it was dropped. So the domain only makes sense for positive values. So I could just say like starting at x equals 0. See, now this is even better because like there's the apple dropped from the tower. Okay, the height of the apple, even though like it might be dropped straight down, but this is like representing the height at different points in time. So how many seconds does it take to hit the ground? 1, 2, 3, 4. Okay, so it's going to take 4 seconds. Now we have to do this algebraically. So let's see here. So we're going to set negative 16t squared. Like we already know t equals 4. Like that's what we should get as an answer. So let's at least get our partial credit. But we set this equal to 0. And there's a few ways we could do this, but I would start maybe by adding 16t squared. Because I don't have to factor this. Like I could use difference of 2 squares, but it's kind of unnecessary because this is only 2 terms. So 256 equals 16t squared. Divide both sides by 16. And then t squared is equal to, I believe that's a perfect square. Yeah. And then square root both sides. Now technically t equals plus or minus 4. But here, did they give us a domain? The number of seconds. Oh, after t seconds. So here I would just, you know what, we don't even need the plus or minus. We could just say like from here, like t equals 4 is fine. All right, that's really all we need to say here. If you want to make mention here that it's plus or minus, you know, you can, but like domain wise, we're not going back in time. We're only going forward in time. Okay, so the apple, like it was dropped. It wasn't like it was thrown and it was following that parabolic path. It was dropped. So we could ignore, like technically, this bothers me because just know the square root of x squared is not x. It's plus or minus x. Okay, square root of x squared we could say is absolute value x. And you could even fact check that in a calculator if you took the square root of x squared. All right, the square root of x squared would come out, if I press zoom 6, in a V shape. All right, absolute value x. All right, so for 30, we just have to do some algebra here. So let's do the algebra. And for this one, I would start by distributing the minus 2/3. So I'm going to have 6 minus 2/3 x. And then here, I'm doing this in my head, but I'm going to have minus, because I have a negative times a positive, and 2/3 times 5. All I have to do here is call that 5 over 1. 2 times 5 is 10 over 3 like this, equals 4x. Okay, so now what I want to do is I want to get the x's on one side and the constants together on the other. Now, one thing I could do here also is call these with denominators 1 so that I can make common denominators. Because the only way I'm going to combine 6 and minus 10/3 is if they have the same denominator. But look, if you really want to, people are looking at that like, oh no, fractions terrify me. Like, let's say I have to do 6 minus 10 over 3. I could just do 6 minus 10 over 3. And then I could press math, enter, enter. And it's 8/3. All right, so you could do that. And if I have to do 4 plus 2/3 in a moment, like 4 plus 2/3, I do this, and I press math, enter, enter. And I get 14/3. All right, so if you want to do stuff by the calculator, like use a calculator. It's not a big deal. You know, they're not going to make you show the fraction math. But if you want to see the fraction math, I'll do that too. All right, so here I would do times, I'll use this symbol for multiply, since now we have x's involved, and this one also times 3 over 3. So this would be 18 over 3, and then minus 2/3 x, minus 10 over 3, equals, and we'd have 12x over 3 like this. Okay, so that's one way of doing this. You know what, actually, I think I like another way of doing this. Sorry if this is depressing people like me doing this. I'm going to show a different way because I think people prefer actually when the fractions are destroyed. So let's destroy the fractions. Okay, so destroy the fractions, even though our answer at the end is going to be a fraction. So here I'm imagining like a denominator of 1 and a denominator of 3. So we could multiply everything by 3. Now the reason why I'm choosing 3 is if I have 1 and 3, the least common multiple, I don't know why I wrote a bad M here, the least common multiple, if we start counting by 1s and start counting by 3s, the least common multiple is 3. That's why I'm multiplying by 3. Because I'll have 3 times 6 is 18. I'll have 3 times minus 2/3. And this is if I'm doing this in my head. 3 times minus 2/3. 3 over 3 cancels. And now I have minus 2x. And then if I do 3 times negative 10/3, 3 over 3 cancels, and I have minus 10 equals 3 times. So now I distribute. Let's just make space here. Distributed here, distributed here, distribute here. 3 times 4x is 12x. So this is much nicer now. So here I would combine these two. 18 minus 10 is 8. I have 8 minus 2x equals 12x. And now I'm going to add 2x to both sides. So plus 2x on both sides. And now I have 8 equals 14x. And then from here, I just divide both sides by 14. Okay, and then this is going to give us x equals 8 over 14. Then just reduce your fraction, divide top and bottom by 2, and x is equal to 4 over 7. All right, so destroying the fractions, I think, is the easiest way to do this. And to do that, you have to multiply everything by the least common multiple. Okay, so that's like a really nice trick to have for solving these kinds of equations. All right, cool. All right, moving on. So let's see here. Unless questions in the chat, let's see. Is the chat going crazy? Oh, wow, the subscribers are flying up here. We're about to hit 23,000. Look at this. So I haven't looked at the chat in a while here. So let's see. Living environment, blah, 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 blah. Oh, good. I'm glad everybody's chatting it up here. Keeping the chat rolling here. All right, question 31. These questions are kind of annoying. You just have to write a sentence. When they say explain, that means like write a sentence, okay? So write a sentence is what you have to do. So looking at this, is the product of radical 16 and 4 over 7 rational or irrational? So look, you could use a calculator here. Like if you really don't want to think like too hard here, just do, you know, radical 16, which is 4, all right, times 4 over 7. So alpha y equals enter, and we got 4 over 7. And that's going to give you 16 over 7, okay? So radical 16 times 4 over 7 is going to give you 4 times 4 over 7, which is 16 over 7, okay? So this, you could honestly just like circle rational and like you already got partial credit. Now, if you don't know the difference here, a rational number is a number that it can be expressed as a fraction, okay? Expressed as a fraction, like where the numerator and denominator are integers, okay? So as long as they're integers, all right, obviously the denominator can't be 0. Like, you know, I'll mention that, like denominator is not 0. So that's what a rational number is. So here, what can we say is the product rational or irrational? We could say rational. So the product is rational. So the product is rational because, and how do we explain this? Well, we could say square root of 16 is rational. Like 4 as a whole number is rational. 4 over 7 is rational. And the product of two rational numbers is rational. Okay, so the product is rational because the product of two rational numbers. So the product of two rational numbers is rational. Okay, and like that's really all we need to say here. Keep in mind, these are only 2 points. So you don't need to write like this massive story as to why this is true. All right, like just get what you need to get down on paper and like you'll be golden. All right, cool. So moving on here. And all right. Oh, wow, we got 1,840 people. Check this out. That's so cool. I'm like happy this is traveling far. You know, even though we're like limited to New York here, it's getting people all around the city. All right, so I'm just very grateful to have you all here, like supporting the channel. Thank you. All right, so this one here, 32. Let's see. All right. So moving on, question 32. So let's see. So f of x, we want to graph this piecewise function here. And I'm going to take a short break just to check on my kiddo. All right, so call this intermission. All right, I'll be back in 5. All right. Yeah, so short break over here. I'm going to try to resume. Hope my kid will hold out. I hope I'm not talking too loud because he is next door. All right. So, yeah, I know small living spaces here. That's a New York thing. So, yeah, also dad of 2. So, all right, moving on. So, piecewise function. And let's see. We want to graph this. Let me just get this a little bit zoomed out here so I have space. So I use this as the angry neighbor. Oh, we're all New Yorkers here, right? So angry neighbor. If you park in front of someone's place, they might get annoyed. And they might say like, hey, like, why'd you park in front of my house, right? Especially Staten Island. That's a common thing. People get very territorial about their parking spaces. So I view this. This tells you, like, don't write this on the Regents. This tells you where to park. Okay? So the most common mistake, I'm going to say this, don't do this. Like, oh, negative half x. Let me fix that. Like, oh, negative half x. 3rd time's the charm. And y equals x. Like, don't make this a system. All right? This is not a system of equations. All right? You knowing how to graph those is, like, nice. But the most important piece to look at here is that x equals 2. All right, that's the most important part, because if you were to just graph, like, let's say y equals x, you would do this, right? You would just plot these points. You would connect them, and like that would be great, right? If they told you to just graph y equals x. But what they're telling you here, don't copy this yet, is only do this. This is telling you where to park it. You could only do this for x greater than or equal to 2. So that means like everything to the left here, like that's gone now. Okay, so like if I had to make a table here, let's say for y equals x, so I make a table of values here for like, you know, like x, and the function here for x greater than or equal to 2, like I'm only allowed to use x values like 2, 3, 4, 5, 6, and here it's like the function is just y equals x. So the x and the y's are the same, like this. So it'd be the point 2, 2, it'd be, you know, the 0.33, 4, 4, and so on like this. So like 2, 3, 4, 5, and 6. All right, but then for this part, when x is less than 2, all right, x less than 2. So f of x like this. If you're less than 2, I'm going to include 2 in my table, but I'm going to say open. All right, that's a common mistake people make, is that they like don't include 2 and like they don't get close enough. All right, so 2, but we're going to keep it open. So if I plugged in 2, negative half times 2 would give me negative 1. All right, or I could just think of rise over run here. Like I have a y-intercept here of 0, and my slope, see how like my slope is negative 1 over 2? It's like I'm going down 1 over 2, like this. And if I want to go backwards, I'm going up 1 to the left 2, like this. All right, otherwise, like I'm going backwards. I have x less than 2, so then I have 1, 0, negative 1. And if I plugged in, I would have negative half. If I did negative half times 1, if I did negative half times 0, I would get 0. And if I did negative half times negative 1, I would get positive half. And if I use one more like negative 2, negative half times negative 2 is positive 1. And you see how it's starting to give me these values here, like at negative 2, negative 4, like this. Okay, so if you had to, though, obviously, like just use a calculator for this part. Like you could graph them one by one and say like, all right, negative half x, like times x, and then like just go to the table. And you see how that table matches? Like we had 2, negative 1. I'm sorry, did I type in the, so negative half, let me just fix this. So negative half, I'll just write it like this. Negative half times x. So there it is. And if I look here, so negative 2, 1 is good. We had 0, 0, and we had 2, negative 1. All right, so you see, like you could get these values in the table. If you're like, wait, I don't want fractions, I want decimals, you press mode and you switch your answer from auto to decimal. Okay, and it'll give you like decimals instead. So that's another way of getting these points, and you plot them and then you connect it. But remember, this part here is open. All right, that's an important detail, that this part here is going to stay open. All right, so this part is open. And then I just connect. Now for this, I would just label this part, like this part here is like the negative 1/2 x. And then like this is like, yeah, let me make that a little neater. I can say this is y equals negative half x. And then this part here is the y equals x piece. Okay, so just so it's labeled, but remember this part is closed and this part is open. Okay, so yeah, that's this question, a little bit annoying, but not too terrible. Okay, so this one here, blah, 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 rabbits, population. All right, so I'm thinking of this formula. So immediately what comes to mind is the amounts is equal to the principal times 1 plus the rate to the power t. All right, so here, explain what 20 and 1.014 represent in the context of the problem. Well, we're talking about rabbit population. That's P of x. So this is like the initial. Okay, so the initial at time 0, at time equals 0. Because look, if you even just type this in, like the calculator really is like a very useful tool for this test. So you've got 20 times 1.014 to the x. So 1.014 to the x like this. And why is, oh, okay. So I look at why did nothing show up? Press second graph. It's starting at 20. Our table starts, or our graph only goes up to 10. So if I were to make our graph go up to like, let's say 100. See how now we could see this? But I don't really need all that much. I mean, I could like make this shorter. I'll make it go to like 40, let's say. See, now it's like a better picture. Okay, so what does the 20 represent? 20 represents the initial population of rabbits. If you go here, see at time 0, there's 20 rabbits. When, what is this? X represents the number of days. So by like 8 days, there's 22 rabbits. And then it's growing it's constantly growing. So here, explain what 20 and 1.014 represent. 20 is the initial population, and 1.014 is the rate of change. Okay, gives us the growth rate. All right, so that's all I would really say here. Get my notes already. So 20 is the initial population. So 20 is the initial, the initial number of rabbits, or the initial population. So initial population. And we could say here that 1.014 is like the rate of growth. Okay, so is the rate of growth. But the idea is that it's coming from this exponential growth formula. Like, I know this is like technically like compound interest when we're talking about, when we're talking about like growth in finance, but you could use it for population of rabbits and stuff. So yeah, just floating that out there. All right, let's see. So looking at this here, oh wow, we have 220 people on right now, 2,000 views total. So anyone just joining, once again, thank you for joining. And if anyone has not subscribed yet, and wouldn't mind hitting that subscribe button, we're closing in on 23,000 subscribers. So I appreciate your help, getting me there. All right, so determine to the nearest tenth the average rate of change from day 50 to day 100. So for this one, please don't do this. All right, don't scroll to 50. All right, I mean, I guess it doesn't take crazy long. Like, you could do it. There's a better way to do this. So average rate of change, you should know this formula. Okay, so like know this. Like, you need to know f of b minus f of a over b minus a. That's the average rate of change from like on the interval from a to b. So if we're going from 50 to 100, and is this f of x? Oh, p of x. All right, so we're going to use p. So we're going to say p of 100 minus p of 50 over 100 minus 50. All right, that's what we're finding. So determine to the nearest tenth. That's all we have to do is determine. So here we go, calculator magic. Alpha y equals enter, pulls up a fraction. And I'm going to press second trace y1. And I'm going to put parenthesis 100 and close it. Minus, once again, if you don't have the new calculator, you could press vars, go to the right, function y1, and you could get it from there too. All right, and then let's pretend you don't know 100 minus 50 is 50. So 100 minus, make sure you write 50. And that's going to give you 0.8. Okay, so this is 0.8. That's it. Okay, so just know the formula and you're golden. All right, if you don't like doing it that way, you could always do this. Remember, press second window, switch the table to ESC, and then check out 50 and 100. And you just go up to the numbers like this and just do this number minus this number divided by 50. And that also works. Okay? So yeah. Cool. So moving on. Oh, this one's annoying. All right. So this one, you need to know this formula. So the next question here, it helps to know this. Like, if you could do these questions in your head, then great. But I'll show you, like, this formula is like nice to know. The point slope form equation. So here there's two parking garages in Beacon Falls. We have garage A charges $7 to park for the first 2 hours, and then each additional hour costs $3. Garage B charges $3.25 per hour to park. So now this is the tricky part. When a person parks for at least 2 hours, okay, so for at least 2 hours, write the equations to model the cost of parking for a total of X hours. So that means we're considering here the domain is when X is greater than or equal to 2. Okay, so we have to know this is when X is greater than or equal to 2. So the idea is, like, the trap would be, if you're not careful, you might just say, let's see. So the garage A charges $7 to park for the first 2 hours, plus each additional hour costs 3. So you might say, like, oh, Y equals 3X plus it's like $14 for 2 hours. Like, if you do something like this, it's going to be wrong. All right, so just you really got to think carefully about what's happening. I'll leave the trap up there though, so we can say why it's wrong in a moment. But here, what you want to know is like the rate here for garage A, like the slope M is equal to 3. Okay. However, what we're starting at here is we're starting at when X is equal to 2. So when 2 hours goes by, garage A charges $7 to park for the first 2 hours. So that means in 2 hours we paid $14. Okay, so this is how much, like this is the cost for 2 hours, because it's $7 for the first 2 hours. So we're basically writing the equation of a line that has a slope of 3, but it's starting at the point 214. So here, that's where you would say y minus 14 equals the slope is 3 times x minus 2. All right. So once again, we're going to see why this trap like is here, because a lot of people are going to write this as and it's going to be wrong. So this would give you, you'd have y minus 14 equals 3x minus 6. And then when you add 14 to both sides, that's going to give you y equals, and you'll have 3x plus 8. All right. So just actually 1 second, something here. Oh, wait, 1 minute. Garage A charges $7 to park for the first 2 hours. All right, so my bad. I just have to adjust one small detail. So it was $7 for the 2 hours. So I just make that a 7, and we're golden. All right, so let me just fix that. Sorry about that. Yeah, they said it's not $7 for each hour. It's $7 for the 2 hours. So that would be y minus 7 plus 7 plus 7, so plus 1. And we're good. All right, now the reason why this one is no good is because it's not accounting for the fact that we paid, plus the bear trap here, it would change the bear trap. It would be 3x plus 7. So the reason why this one is no good is that let's say x equals 1. So 1 hour of parking should be like, let's say $3.50. But if you plugged in x equals 1, you get 3 times 1 plus 7, which is equal to 10. All right, so yeah, like that's why it wouldn't match. But if you plug in this one here, you're not allowed to plug in 1. You can only start at 2. So the shift here is going to make this tricky. Like that's something you just have to be careful with. And it's for when x is greater than or equal to 2. All right, so we're not going to step in that trap here. Once again, I play around with numbers just to make sure that I'm good. Like I check my answers before I go. Like that's like kind of how I knew like something was like didn't seem right. But yeah, the detail here, once again, it's $7 for the first 2 hours. So after like 2 hours, we pay $7. So we're starting at 2.7, but then our rate of change is $3 for each additional hour. So this is for, garage A. All right, so this is for A. Now for garage B charges $3.25 to park. So for this one, we're also going to be starting greater than or equal to 2. All right, but they don't have any like weird conditions here. They're just charging you, like a nice rate here, $3.25 per hour. So here, this one, we could say like y equals 3.25 times x. However, we're starting at 2 hours, and at 2 hours, that would be $6.50. So you see here that we're going to account for the change. So once again, we could like kind of play that guess and check game, but I think it's going to be easier here. Like this formula, star this like 5 times. This is like $1 million formula here. Like we're starting at 2,650, and what's it called? We're starting at 2,650 like this. So we're going to use, we could just use this formula again. Now here, like if you just know like, oh wait, if it's 3.25 per hour, like doing this in my head, I know like garage B is going to be y equals 3.25x. But this formula is like just such a golden formula here. All right, it's like really helpful to have. So 325 represents our slope. So now I use that formula. I have y minus the y value is 6.50 equals the slope is 3.25, and then we've got x minus 2. So then y would equal 3.25 times x minus 2, and then we just add the 650 to both sides. Okay, so plus 650. And now this, if I distribute it, I would get 325x minus 6.50 plus 6.50, and these would just cancel out. So y equals 3.25x, right, is garage B. So now we have both equations. All right, so write equations to model the cost of parking for a total of X hours in garage A and garage B. Now we have to determine algebraically when the cost of both garages will be the same. So this just set them equal. So now you would set 3x plus 1, because that's y equals this, equal to 3.25x. And then here, just subtract 3x on both sides. And you got 1 equals 3.25 minus 3 is 0.25 times x. And then just divide both sides by 0.25. All right, and then this cancels. X equals 1 divided by a quarter. There's 4 quarters and $1, so x equals 4. So here we would just say x equals 4. Here's our solution. Yeah, write as much as you can for part 2, 3, and 4 so that you get your partial credit. Yeah, try not to leave like any of that stuff out. Oh, cool, my green screen is holding up behind me. I'm just checking the, yeah, everything's working fine. Cool. So how are we doing in the chat here? Wow, we have 216 people, and how do we do? All right, subscribers are moving up too. I really appreciate you all too. Thank you so much for like joining on this live stream here. All right. Oh, 35. 35 is annoying. This is like my least favorite kind of question to do. It just takes up like a ton of time and like mental power. All right. So let's see. All right. So 2y plus 3x is less than or equal to 14. So you have to graph the system of inequalities and then determine if this point is in the solution set. So for this one, the theme, it's very annoying. Like this, especially the first part, this is the big idea. So this is a big idea. Like, be good at this formula. Get it in the form y equals mx plus b. So this first one here, I'm just thinking like, all right, 2y, if I do minus 3x on both sides, that's minus 3x plus 14. Okay, so yeah, like if I show that on the side here, I'm just doing minus 3x on both sides, which would give me, like this is gone, minus 3x plus 14. Then I divide everything by 2. So y is less than or equal to, this is, I could write this as negative 3 over 2 times x plus 7. All right, now for this, I would graph this first. Go up 1, 2, 3, 4, 5, 6, 7. This tells you solid line, okay, because it has an equal to. And this tells you like the rise over run. So I'm going to go down 3, down 1, 2, 3, and then to the right 2. Okay, so I'm going down 3 over 2. So down 1, 2, 3 over 1, 2. And I'm just going to do this a few more times. Now let's say I mess up. Let's say like, all right, this is my next point. See how it's not a straight line anymore? So if you mess up, like you'll be able to see it. Like, because it won't be a straight line. And then up 1, 2, 3 over 2. All right, so here is the first one, but then we have to shade. Okay, so make this a little neater. Yeah, this is not easy to do with one of those drawing tablets. Now, one thing to point out here, you also have to label. So I would label this one here. This is, like I just pointed out, and we're less than or equal to, so I'm shading this way. All right, so I'm shading under. Less than, shade under. Equal to, make the line solid. Okay, so we're shading under. So this is 2y plus 3x less than or equal to 14. Now the next one is a little bit easier to work with, or I guess in a way it's easier, but or maybe not. So this one, do minus 4x on both sides, and then you'll have minus y is less than negative 4x plus 2. And then this one we have to divide everything by negative 1. And just know there's another trap. When you divide an inequality by a negative or multiply by a negative, the sign flips. So now it's going to be y greater than negative 4 over negative 1 is positive 4. And then 2 over negative 1 is minus 1. So, I'm sorry, minus 2. I did 2 minus 1 is, yeah, I'm tired. It's the end of the day. 2 divided by negative 1 is negative 2. All right, so this is what we want. 4x minus 2. Once again, this is your y-intercept, and this is your slope. So the y-intercept, the b value tells you where to begin. So I'm gonna begin at -2, but be mindful, this is gonna be a dotted line, okay, or dashed. I forget the vocab, but whatever. Just so -2, I'm gonna make it open. So everything about this is open. If you want though, like you could put points like this and then just put dotted line connecting it, like it's fine. Or you could put open. I'll just make them solid like this because I think it looks nicer. So now I'm going to go, my slope is 4. So I'm going to go up 1, 2, 3, 4 and over 1. 1, 2, 3, 4 over 1. 1, 2, 3, I can't count. 1, 2, 3, 4 over 1. And then down 1, 2, 3, 4 to the left 1. Remember, it should stay on a straight line here. That's how you know if you're messing up. 1, 2, 3, 4 and then left 1. And then connect it with a dotted line. All right, not my best artwork, but it's good enough. And greater than, so we're shading above. So we're shading this way. All right, once again, this is not easy to do with this drawing tablet, but I'm doing my best here. Okay, so there it is. I would label this one, was originally 4x minus y is less than 2. All right, so that gets you like tons of partial credit. But now is 1, 2 in the solution set. So let's look here, over 1, up 2. Is this in the solution set? And this I'm going to say is not. Okay, just looking at this is not in the solution set. So 1, 2 is not, because this is a dotted line. So we're not, when you have a dotted line, it's not inclusive. So here I would say no. Now for the explanation, we could say there's a few ways we could do it. I personally like to just plug into the original. So if I plug in here, I'd have, let's say to the original. So this is my x. I'll make that neater. This is my x and this is my y. If I plug into the original, I'm going to have 2 times 2 plus 3 times 1 is less than or equal to 14. And if you check this out, that's going to give me 4 plus 3 is less than or equal to 14. 7 is less than or equal to 14, and it checks. However, the second one, if you plug into the second inequality, you're going to get 4 times 1 minus y is less than 2. And this is going to give you 2 is less than 2, which is not true. Okay, so now to answer this, is this in the solution set? We would say, like, determine if the point, like 1, 2 is not in the solution set. Because, we have to explain, because 1, 2 does not satisfy both inequalities. Okay, so that's just all you have to say here. You could say like it doesn't lie in the solution set, like on the graph. Yeah, so you can pass with just the multiple choice, but it's good to try to like get points in the free response too. Depends what your goal is. All right, where are we? 36. We are almost done here. How much time have I put into this so far? Oh wow, 2 hours and 23 minutes. Yeah. As soon as I'm done with this, I'm going to take a few questions, like just to give people the pep talk, and then we'll call it a day. So this one, we have a table for x and y, linear regression. So this is all calculator. So just go to the calculator. So for this one, let me shrink this a bit. Okay, so I go to the main screen, and what I'm going to press here, let me just, okay, so I'm going to go to stats, edit, and then I'm going here to just enter the data. So 27, 12, 13, oh, this is annoying. All right, 10, 30, 45, and 20. All right, and then if you go to this column, it's 46, 28, 45, 34, 56, 67, and 42. All right, and now we're calculating a linear regression. So calculate linear regression. So that's number 4. And there it is. Now you'll notice there's no R value here. So what you have to do is, if your calculator's reset, press second 0, go to the catalog, and instead of scrolling down to D, you can press alpha and then X -1. What that does is it selects the button D so that you don't have to keep scrolling. Make sure the diagnostic is on. Okay, because then when you go to stat, calculate linear regression, I believe when you put the diagnostic on, it gives you the correlation coefficient with it. Okay, so that's something, it's one of those annoying things that if you don't know, like you'll just kind of be miserable at the Regents. So just know how to do that. All right, so write the formula now. And we have to know how to round to the nearest hundredth. So here, see how it's in the form y equals ax plus b. So you can even write this out just in case you round wrong, like y equals ax plus b, like a equals 0.9577, whatever, b equals 23.94864, 23.94864, whatever. So then to the nearest hundredth, you would have y equals 0.96, because you see here your hundredth place is a 5 and to the right is a 7, so we round up to 0.96, and then we tack on our x, and then we tack on our b value is 23.95. Okay, so we got 23.95. All right, so this would get us credit for the first part. Now the next part is we have to state the correlation coefficient, and here we're rounding to the nearest hundredth. So R is equal to 0.92. So this is 3 points. This is 2 points, 1 point. The last point is to explain the meaning of this value in the context of the data. So I didn't even read what this data was about, but just know that this is a strong correlation. Okay, strong positive. Like really you could just be between -1 and 1. And this is like kind of neutral. Like you know, this one here in the middle is like just neutral. This is strong and this is weak. So if you're really close to 1, like that's a strong positive correlation. And now I read this. So what are we talking about here? The percentage of students scoring 85 or better on a math final and English final exam during a recent school year for 7 schools is shown in the table below. So the percentage of students scoring 85 or better. So here, what this is suggesting is there's a strong positive correlation between scores over greater than or equal to 85 on math and English. Okay, so then I would just write that out. Like there is a strong positive correlation. Okay, so there's a strong positive correlation between, and then once again, if you get like jammed up, between the percentage of students scoring 85 or better on math and English. Okay, between the percentage of students, and then I just like literally just copy the question over again. Scoring 85 or better on math and English. Scoring 85 or better on math and English. Okay. Whoops. Yeah, I'm really just fried right now. We're almost at the end. All right. So math and, okay, we'll capitalize it. Math and English. Although they're not going to zap points for grammar. So cool. Oh yeah, in the 7 schools. But whatever. This is fine. Yeah, so in the 7 schools. Because there were 7 schools, right? In the beginning? Yeah. For 7 schools. All right, cool. So moving on here, let's see. How are we doing on? All right. Oh, wow. We passed 23,000 subscribers. Thank you, everybody, for helping out here. This is so cool. Yeah, it's like just really, it's been a wild ride, like seeing the channel get to where it's at. And I owe it all to all of you. How do we find the solution to an infinite geometric series? So at Dante, that sounds sort of calculus related. Yeah, I'm going to do Algebra 2-ish review. Unless it's for Algebra 2. Like, I'm going to do a live stream for Algebra 2 and for geometry. So right now I'm kind of sticking to the Algebra 1 stuff. Yeah. Let's see. So question 37. Oh, the final boss. 37. So Dylan has a piggy bank, right? Of course he does. Okay. Let's see. And blah, blah, blah. Coins. The panel shows, he has 90 coins with a value of 1755. So he collects dimes and quarters. Write a system of equations in two variables, or an equation in one variable that could be used to model this situation. All right. So he has dimes and quarters. So for this one here, I mean, there's a few ways we could go forward with this. If you want to write this in, what's it called? With all integer, like just whole numbers, then you can. But just know here, like we could use, I want to make sure, do they tell us to use a specific variable? Because I think we could just name this anything we want. But whatever. Why don't we use like X and, or we could use dimes and quarters. I guess I wouldn't use like S because S looks like a 5. So that's the only letter I don't like using. But D and Q is not bad. So 10 dimes. I'm sorry, 10 dimes. Each dime, so this is how I think about this. So a dime is 10 cents. Okay, a quarter is 25 cents. So it's the value of the coin times the number of coins plus the value of the quarter times the number of quarters equals how many cents is this? That's 1755. Okay. If you want to do this, this is okay. You could say 0.10 plus point this equals 17.55. You could do that, but don't do that to yourself. I think it's going to make it more confusing. But remember, the panel shows 90 coins. So the number of dimes and quarters is equal to 90. This takes care of the first part. Okay, so write a system of equations in two variables, or an equation in one variable that could be used to model the situation. Like there's our system. Okay, use your system of equations to algebraically determine the number of quarters. Okay, so we're solving for the number of quarters. So here what I would do is we have to eliminate a variable, but if we want to solve for quarters, we're going to eliminate dimes. So we're starting off with 10 dimes. I'm sorry, I keep saying 10 dimes. 10 times D plus 25 times Q equals this. And then we have D plus Q equals 90. I would multiply the bottom row by negative 10. And then what that's going to give us here, we're going to have 10D plus 25Q equals this. Like the top equation is going to stay the same. The bottom equation is going to be minus 10D minus 10Q equals minus 900. So now when we add these two, dimes, like this eliminates, and we have 15Q equals, and if we subtract this, let's see, 755, 855, I want to say, but I'm going to use a calculator to double check. So let's see, 1755 minus 900. 855. And then we have to divide by 15, so we might as well do that now. 57 quarters. Okay, so divide by 15. And then Q equals 57. Let me make that a little neater. That was like not my best handwriting. All right, now what I would do before I move on, like I would check. Okay, so then if there are 57 quarters, that means the number of dimes, remember like D plus Q is 90. That would mean there's 33 dimes. And then I would just run it through and just double check that 10 times the number of dimes plus 25 times the number of quarters equals this. That would just make me feel safe, all right, to do that. So 10 times, there was 33 dimes, plus 25 times 57 quarters, moment of truth, equals 1755. All right, so that's how I feel, like that's when I feel good about this. Cool. All right. So let's see here. Oh, explaining in the amount of time we get. Oh, so at Josh, just know I went on a lot of tangents. All right. Like people were asking me like just random questions that like weren't about this Regents. If I'm going full speed ahead, like if you watch my walkthrough videos, like I do the whole test in like around an hour or so. And that's me explaining it. If I was taking the test myself, like, and I was like racing, like I could do the test in under an hour for sure. I could do it pretty fast. Like I wouldn't necessarily get 100 if I go hyperspeed, but I would say I would be able to break like 95 like if I go really fast. I have to take my time if I want to get 100. All right, emotional support buddy. It's all right. Just remember, I know it's tough because it's the night before the test, and it's like, yeah, it means a lot, but the worst that happens, like if you don't do well, you get another shot. You know, when you're all young, you get like your windows are still wide open. I didn't do well on every test I ever took in high school. Like some of my students think like, oh wow, you must be so smart, like blah blah blah, like you must have always got things like, you know, like hundreds all the time. I'm like, well, no, in college I messed up a little bit, so like it's all right. All right, let's see. So Dylan's mom told him that she would replace each of his dimes with a quarter. If he uses all of his coins, determine if Dylan would have enough money to buy a game that's this expensive if he must also pay 8% sales tax. All right. Well, remember, he has 90 coins. So his mom says, I'm going to give you all quarters. Okay. So that means if we look here, we'll do the calculator again. 90 quarters is 90 times 25 cents. So that's $22.50. So we'll say that 90 times 0.25, and don't get old, $22.50. Okay. Okay, so we could say this is like Dylan's like total money. All right, now the game, how much does the game cost? It's $20.98. So the game costs $20.98, but he also has to pay 8% sales tax. So that means we can multiply by 1.08, because just know 8% is 8 out of 100, which is 0.08. And what I'm thinking of is that formula from before. Remember, the amount is whatever you're starting with times 1 plus or minus the interest rate. And the interest rate here is 0.8 like this. So that's why, and it's like, we don't have to worry about the exponent t because it's just like a one-time tax rate. Okay, they're not gonna charge you 8% tax like every week. That would be insane. We would all be broke. So 2098. So 20.98 times 1.08. We're talking about money, so we're just going to say 2266. Okay, let's just see here. Yeah, so 22. I'm just double checking one thing here. So 2098, 1.08. Okay, so this is going to be 2266. But now, if you look at this, all right, at 2266, does he have enough money? Well, no, because Dylan has 2250, but the game, this is the cost of the game with tax. Okay, so that's something to consider here. I just want to check the rubric on one thing here. Let me just see, 22. I want to check one thing at the end here because I noticed in one of the solutions, I just want to make sure everything is airtight before I, let me just see. All right, so this, blah, blah, blah. What is the cost of the game? Oh, okay, so they just went by this. So yeah, 2098 times 0.08. I just want to double check that my numbers are, because I'm checking how the full credit solutions, just to make sure, like, because I know he doesn't have enough money, but right now it's like looking like, let me see if you do it this way. 160. Oh, you know, our numbers are good. Yeah, our numbers are matching. So, because, yeah, if you do this plus 2098, it also gives you 2266. So, yeah, we're fine here. We only have to justify our answer. We don't have to write a sentence. So, we would say Dylan does not have enough money. Okay, and if you want to say why, just say because, the cost of the game is greater than Dylan's total money. Okay, so the cost of the game is greater than Dylan's money. And we're good here. All right, like that would get you full credit. Yeah, because I noticed, I think, when I checked one of this, there was like a small typo in someone else's solution somewhere. So yeah, that was unfortunate. All right. I know, 15 cents, and he gets rejected. But that's how the world works. All right. So I'll just, I'll say like non-math questions for now. If people just want like overall advice or something, I could talk for a little bit more. What time? Oh, we're at 10:09. So yeah, just I guess a few more minutes I could chat. 2098, where did that come from? They just made up a random price of the game. So that's just a random price. So any other... Oh, the Regents for living environment was tough. Yeah. Yeah, well, just know all these Regents are just practice, like you just got to practice until... Oh, my bad. I had this on the main feed. That would just be, kind of like making one of those infinite loops. What's it called? Yeah, just, I guess, get your practice in. Do the best you can. Linear regression on a calculator. Oh, if you so Lainey, if you go back to question, where was it? Question 36, just rewind. I went over that, okay, on how to do that. And I also I'll show how to diagnostic. So at Sonam, video games, yes, I used to play a lot of video games because I grew up in the 90s. So one cool thing about the 90s was I got to watch video games evolve from what they were then to what they are now. So I started out on regular Nintendo, went to Super Nintendo, N64, PlayStation 1, all the way up to... I didn't get a PS5 though, because like I have 2 kids now, so I really don't spend that much time gaming. Any free time I get, I'm doing YouTube. I play a lot of chess. I play a decent amount of chess. Like I'm pretty good at chess. I'm not a master, but I'm like kind of like expert level. Where am I from? Oh, I teach out of Staten Island, New York. Yeah. So I'm a Staten Islander to my other fellow New Yorkers. What topic? Oh, that's a good question. What topic most commonly? All right, hang on. Algebra 1 Regents topics by percent. That is a good question. Let me see. Was this the page that had it? This page might have. Yes, this page does have it. So I'll screenshot a few things. All right, let's see. So I will go. We'll get this. This one. And yeah, so when we talk about like what you want to be good at, and let me see how current this is. Make sure this is like a legitimate, because this is like the kind of things I look up with my students, like when I prepare them in class for any sort of thing. But you could see here like real numbers, using units. It's like a small percent of the test. The stuff you want to be really good at, like be good at algebra. Like writing expressions in equivalent forms to solve problems. Arithmetic with polynomials. Oh, relationship between zeros and factors is big. Creating equations. Solving equations and inequalities. Represent and solve equations and inequalities graphically. Systems of equations. Like your algebra should be really good. All right, like that will like seal the deal for you on the Regents. So like be good at algebra, and then functions is really big. Interpreting functions, like what's the meaning of a function, using the notation, applications of functions, like what they mean, and also like building functions that model relationship between two qualities. So that's like the calculator stuff, and building new functions from existing ones, and construct and compare linear, quadratic, exponential models and solve problems. So a lot of this is like calculator stuff though, like you could get away with. And then like stats and probability. So like be good at algebra and be good at the calculator will get you pretty far in algebra 1. But once again, like I wouldn't get too stressed out. I know it's hard to say because like your test is tomorrow, but like don't drive yourself like too crazy about you know, what's it called? Don't drive yourself too crazy about like being so amazing tomorrow. Like at this point of the game, like the test is like, you know, pretty close. So just, I would say like, you know, get some sleep. Don't drive yourself too crazy and use tomorrow as like a learning experience. If you are anxious, try to convert that energy to like excited energy, you know, and show up and just do the best you can. And that's like your best bet here. So yeah. So any others in the chat here? 187 of you swinging by. Oh, the in real. Oh, love the calculator on screen. Yeah, this 84 CE is like pretty awesome. Calculator tricks. Go over the vertex form and graphing that. So vertex form, do they still, they ask vertex form? I guess they do. Make one up. Let me see. Something that has a nice vertex here. I mean, the vertex form is, what's that? Like the y equals a times x minus h squared and then plus k. I think that's the equation for vertex form. Yeah, I mean, for this one, like let's say, I don't know, I start with like y equals x squared minus, I don't know, 8x plus 12. So for something like this, I could just say, all right, the vertex, remember the formula x equals negative b over 2a. So that would tell me like my vertex, or like my h value in a way, because the vertex we usually call hk. So I would say like, I could think of this as like my h value. I don't have to write it as my x. So the x of my vertex is negative 8 over 2 times 1 would be equal to 4. And then if I plug that in, like y equals 4 squared minus 8 times 4 plus 12. See how that gives me 16 minus 32 plus 12. And negative 16 plus 12 is negative 4. So my vertex would be 4, negative 4. And my a value is equal to 1. So if I had to write this in vertex form, I take this and I say, all right, y equals a is 1. And I get x minus, this is my h and this is my k. So I get x minus 4 squared. And then my k value is minus 4. And that should do the trick. All right, if I had a check, then I would just expand this. Y equals, expand that. Don't say x squared plus 16, all be said. That's x minus 4 times x minus 4 and minus 4. And if you distribute x squared, my computer's freaking out a little, minus 4x plus 16. And then I tack on my minus 4. So y equals x squared minus 8x plus 12. Yay, it works. All right. I just made that one up on the fly, so I hope that helped a little bit. But this is the formula you need. A Gaussian integral, LOL. Yeah, that message retracted. Yeah, Algebra 1. I'm not going to make everybody depressed. But I wouldn't be able to do a Gaussian integral right now if I had to. So yeah. I will say here, though, we are almost at the 3-hour mark. I am going to chop this. I'm taking this test in 8th grade. What are your thoughts on the importance of it? Okay, 8th grade. I'll say if you want literal equations, so at Edward Jordan, I have a whole video. If you just search my channel on literal equations, it's fairly new. Let me pull it. I'll just link it in the chat. I think it's a pretty good video. I mean, I covered a lot of examples. Only because for me to make ones up on the fly is like not going to be as good as the ones that I'll just have ready. So let's see. All right, literal equations. So I will just hook you up with a video, and then I'll answer that 8th grade question. So literal equations. Oh, I made it in 2020. Look at that. Copy link. All right, so literal equations. Wow, that's already like 3 years ago. Getting old. All right, so there's your literal equations. All right, so taking this in 8th, what are your thoughts on the importance of it? Algebra 1, I'll really emphasize, you really want to be good at algebra. Like that is like absolutely something I would say is so important. Reason being that it's the foundation for like the rest of your math. I would even argue like AP Calculus BC, that's like one of the hardest classes you could take in high school. Some high schools have multivariable calculus, like the gifted, talented like programs. But for the most part, like Calculus BC, it's a hard class. But like you need to be really good at algebra, and like you'll be fine as long as you're like willing to do the work. But like if you're not great at algebra, physics is hard if you're not good at algebra. Chemistry is a bit hard if you're not good at algebra. Like it's just like such a good foundation to have for your other classes. So yeah, that's my 2 cents on that one. Yeah, I have a lot of stuff. They give you a reference sheet for a dimensional analysis too. Yeah, I mean, yeah, you get like the reference sheet does have like plenty of stuff on it. When you're talking about like what's the value for each units and whatnot. So yeah, 168 people right now. And we broke 3,000 views for the live stream. So thank you all for making this possible. I'm going to annual. Oh, so at Valeria, let's see. So $5,000 or $500 in the account, and 1.2% annual interest rate. That's 1.2 out of 100. That's like 0.012. So it's a growth rate. So you're going to add that to 1, and it's to the power t. Oh, call it a of t. And then what do they want to know? It represents the value of the investment t, t years after Alexander's birthday. Annual growth rate. Okay, so that's like, yeah, there's your formula here. This one you want to know, a equals p times 1 plus or minus the interest rate to the power t. All right, like that's just a good formula to have. 5,000, yeah, then just put another 0 and you're golden. Yeah. So algebra 2, so at so at that comment, algebra 2, it's when you have compounded like either continuously or like monthly. So this is like algebra 2, not to scare people, but in algebra 2, it turns into this. It's like a equals p times, it's like 1 plus or minus, it's like r over n to the nt. All right, which just means like, I'm not even gonna get into that, but that's the algebra 2 version. So don't worry about this. But the fact that it was compounded like only once a year, like annually, like the algebra 1, it's once a year. So this is like the algebra 2 one. And then the other one is like a equals p e to the rt. This is like continuous, also algebra 2. So this is algebra 2. So stay tuned. In 2 years, you could check back and we'll talk about that one. Do all the word problems first, then the multiple choice. I like interesting style. Exponential decay is just more about, let's just see here what time. Yeah, I got another 5 minutes and I'm going to call it. But exponential decay, like let's say I had like y equals 2 to the x. Like I really wish that was my bank account, right? Because that just goes up. But exponential decay is kind of a situation here where like your base of the exponent is like basically like between 0 and 1. So I call like, yeah, my base is between 0 and 1. So if I had like 1/2 to the x, that's when like it just keeps dividing things by 2 over time. Okay, so this is like, if it's finance, this is depressing. Okay, or if it's like your debt, then like, yeah, I'm cutting my debt in half every so often. So yeah, exponential decay is when you have like y equals like a to the x, and a is between 0 and 1. Okay, so it's a fraction between 0 and 1. Exponential growth, like same thing, like y equals a to the x, except a is greater than 1. Okay, and that's when you hope it's your bank account. Like, the more the better. Yeah, like I said, if you don't do, like, it's very normal to be nervous the night before a test. That should be like its own thing, learning test psychology. Like, how do you show up to the test with confidence? Well, I would say being confident for the Regents, if you put your time in, like, you got to be honest with yourself. Did you try your best getting ready for this test? Because if you did, it's okay to be nervous, but when you get to the test, use that nervous energy and use that to like get yourself amped up and just direct all that nervous energy at the test. You know, it's when you let the nervous energy take over and like squeeze you and like just make you forget everything is when you lose. But if what I used to tell myself, because I've had great and I've had bad test experiences, is that you really want to like just like say to yourself, like, all right, I put my time in, I'm ready for this thing. The only people who have permission to be like super nervous is like, if you didn't try, like you didn't really study for this thing, then like, yeah, you'll be nervous because like chances are like you might not know a lot of stuff. But then you have to reflect on it and say, you know what, next year I'm going to do better. And that's just it. That's like the whole game of life. Is you have to be honest with yourself and like try to level up. Like that's it. Like if I talk about exponential growth, why not use the channel here to talk about it? But we'll look at the history of the channel real quick. Let me make sure that I'm not see the live count. All right, from all time. Let me see. And this will be, I will end on, actually, no, if I'm going to be able to, oh yeah, I will be able to do this. Okay, so lifetime. Yeah, like, why not look at this for the exponential growth, right? If I look here, like, oh, I'm nervous, like, I want to get better, how long will geometry live stream be? About the same. It'll be about the same. So here, like, you could see I started out, I had like nothing, and my videos were like, you know, not what they are now, but it's just a process of getting better and better. And like, I was putting in the time. Around here is where I froze. I got lazy here because I wasn't, you know, trying like as hard as I could, and I wasn't seeing the results. And it's like very easy to get discouraged, and no matter what it is, it's like, oh, I'm not seeing the results, so like I'm not even gonna try. But the key is you got to try even when you're not seeing the results, because the only way you're gonna enter that swing where the numbers like really start to take off, like they have been lately, like this has been my best year on YouTube by far, is like you really just you got to keep at it. Because I promise you, like, the reward to you working hard is when one day it's like, oh, I want to get a job. They want to hire the people that know how to work. All right. They don't want to hire like people who just like kind of get by. Like at this age, it's fine. It's like your rite of passage to not be working like as crazy as you can. But little by little, you want to just level your game up. Like that's it. But yeah, that's my 2 cents on that one. Yeah, I'm going to review the night before the Geometry Regents and Algebra 2 Regents. So yeah. So any other... All right. Well, we are closing in on the 3-hour mark. So I just want to say to everybody, good luck to all of you. Once again, thank you all so much for stopping by. It really does mean a lot to know. Like my high school has 3,100 people, and we had over 3,100 people stop by. It's like a whole high school, a big high school showed up to this live stream. And the average view time was about 10 minutes. So like that I got to be able to keep you all here, like as long as you stayed. Like, thank you for that. And you're always welcome back. So next time I do a live stream, in the following years, like consider spreading the word and letting people know like that I'm doing this, because I plan on doing this like, each June from here on. And if you take AP Calculus, like I'll be streaming for the AP Calculus exams into the foreseeable future also. All right. But awesome work, everybody. I'm proud that you stuck it out for as long as you did the night before the test. And good luck. All right. Let me know after the test what you all thought about it. And when you get your grades, maybe I'll make like a YouTube short or something where people could let me know how they did on the test. All right. I'll check back in with everybody. All right. So hang in there. Good luck. Put your best math down on the paper tomorrow. And yeah, have a good night. Take care.